I guess it helps if I unmute my mic, everybody. Hello to you out there. It is a bright, alright, it's a dark early morning, not so bright, but that's okay, because we're live. We're live for yet another day of excitement. I'm just going to get ourselves kind of situated here. We're going to let the stream kind of pick itself up a bit, and then we will get to developing some software. I'm just making sure I'm live, making sure everything is up and running like it should be. Looks good to me. Looks good to me. Okay. And I just want to send myself a little test message here. Make sure. Oh, hold on, guys. I don't have. Is my chat working? Where's my chat now? Let's do a little swappy flip here, and then let's see what's up. Let's try it from the other end. Maybe it's just a live coding TV thing. Okay, nope, I got my chat is working out. Good. Nothing like the little testy test. Even if we try, are we working for? I won't give you less. Oh my god, it's definitely breakfast time though, so I'm gonna eat myself a little breakfast while we wait for the stream to warm itself up. And then we're going to get to work. Nummy nums. Good morning, Screamer. Good morning, buddy. Nums. What is going on this morning? That's what I want to know. What's going on this morning? It's kind of early out there, isn't it? Oh, it's so good. Coffee's the best thing ever. Screamer. Well, I'm glad you're feeling better, man. That's funny. Asmus, what the hell are you doing awake so late in the day? Why are you even up? That's pretty funny, Screamer. That's pretty funny. I'm just looking at the stream here. Making sure everything's good. Everything looks good. Everything looks good to me. Well, that was a good breakfast. That was a delicious breakfast. Oh, crap. Hold on. I got to refresh this page. Otherwise, I'm missing stuff. I'm so sorry, Azernus. It's all gone now. It's all gone. All I have left is copy. What's up, Ginix? How you doing, man? How you doing? Oh my god, Kelvin1. Thank you so much for following. I didn't even think anyone was over on Live Coding TV's side of things yet. Just got the stream up and running this morning. But that's all right. So we are in warm-up mode, drinking coffee mode, and then we're gonna get to work mode. It's gonna be a fun day today. We are so laughs. By the way, let's while I'm drinking my coffee, let's see where we left off. Yeah, and I don't know why. All right, this is starting to kind of irk me a little bit. I don't know why Visual Studio 2015 will not remember my Windows settings. Linux not on the weekends. Not on the weekends. I'm here extremely early, right? So where did we leave off? On Thursday night. We had our smooth interpolation going, right? So just so it's clear, we are actually running our simulation here. We are emulating about 200 milliseconds of delay and an about 5% packet loss. But even though we're having all that emulation, we have a nice, smooth, interpolated ball movement here, right? We are not, by the way, applying any velocities to this object. No velocities are being applied. No forces are being applied. This is just pure linear interpolation over time, right? Which is very similar to what would happen if you were trying to apply a velocity in a physics system, right? And rendering on top of that. Enterprise, Kelvin. But because we are two things going on to make this smooth, right? First of all, we have our delay, our ping to from the client to the server is about 200 milliseconds. But then on top of that, we're also building up a minimum of a 300 millisecond buffer for us to have enough data points to interpolate between. So that's why we are this far behind. Today, we're going to crush that number down from 300 to 100 by sending more, by using a higher tick rate. So we're going to get to that. So that's one thing we're going to do. That's a simple thing. Besides some also other cleanup we have to do. I think the big thing we're going to implement today is we're going to get our physics engine into the server and add a physics layer on top of it so we can start using it through the entity component system. And then we'll get to start seeing some non-linear movement. Because obviously what we're simulating here on the server is a very simple movement pattern. So it's very, very easy to linear interpolate over. Let's see what happens when we start getting some erratic movement. You know it, Screamer. But that's where we are. That's where we left off. This was actually a pretty good push for us to get this finished on Thursday. And I think what I want to do is not just render our interpreted position, but also the live position that we're getting in from the server, just so you can see how jittery it would be if we did not interpolate over a data set. And then also you can see just how far behind we are from the live data coming in from the server. I might render that too. And maybe like a blue ball. That's right. I'm gonna send out my tweet, guys. I gotta send out my links. Okay, that's sent. I also need to shut down a few things so we don't get bothered. That should be good. Oops, get these back up. Yeah, all right, let me send out my Reddit link now. Submit. And then submit it again. All right, Reddit link is out. Excuse me, guys. Man, it's early. Hey, good morning, Rick. Hey, Jetty. Hey, Jetty. No work today, Jetty? No work this morning? Morning people are crazy hazardous. Oh, no. Oh, no. Oh, you know what actually might be hard to see on stream? I didn't really think about this when I'm showing our smooth animation here. I actually do my development streaming at 15 frames a second so that I can push a 1080p high quality text stream over low bandwidth. It's probably not so smooth to you guys because 15 frames a second, it probably looks a little jumpy, is going to be my guess. Oh, they don't work on weekends? Well, Jetty, congrats for having a weekend off, man. I'm glad for that. I would really hope that you would start spending your weekends getting back into game development, though. Excuse me. Wasn't going to say anything, Screamer? Yeah, I know. I just thought about that. I'm like, wait a minute. But that's just the life we live in. Maybe we'll get to a point real soon here. Maybe we'll get to a point here real soon where I can publish a client out there. You guys can download it. We can all see it interact with 50 different colored balls flying around the screen at the same time. Because that's a real network test, right? Do something creative and popular. All right, Jetty, that's good. That's good too. I can respect that. Oh my God, Ginix, you're everywhere. You are everywhere. And you are everywhere. All right, guys, my coffee is almost done, and that's gonna signal us to start working. So hopefully you guys are buckled up and ready. Buckle yourselves up. It's gonna get good. Oh, so I also updated my encoding PC to Windows 10. I updated my encoding PCs to Windows 10. I did some test encodes or some test streams. So I'm hoping that my streaming PC crashing issue is going to be going away. Hopefully that's a thing of the past. I think there's a new issue now, and I might have to compile a new version myself, but OBS now is crashing sometimes in Windows 10 because of the browser plugin that I use. Thanks for the follow over there, Ginix. because of the browser plugin that I use. So we'll see, and it's crashing within an internal component within the browser component. But if I just grab the latest of that, rebuild it with the latest browser library, I'm hoping that will fix it. We'll see. But even though it kind of crashes, it still keeps streaming, so it's not that big of a deal. It's not so bad. All right, I gotta get my fan on. Oops. Go. And I'm thinking, what's the very first thing I want to do? I think I'm going to add our ghost render here of where we are in real time compared to where we are rendering in the simulation. I think I'm going to go do that right now. Let's go do it! This should be pretty simple for us to do. Just real quick. And it'll get us warmed up, right? It'll get us all nice and warmed up. So we just want to render in real time in a different color, basically so we can see just how far back the simulation's running and how smooth the simulation is versus real time data. Excuse me. So here's our render, right? So this is rendering out of our interpolation buffer from a point in time in the past. Here's where we're going to get we get the data actually in real time. So I'm just going to do I'm going to loop through in our snap packets dot data points. Oops. We're going to run through all of our data points, and we just want we're going to clear our back buffer first. And then we just want to draw. Just like that. I gotta grab a copy of the form graphics, draw it. There we go, and actually changes from red to blue. All right, let's see what this does. Look like a Halo pistol. Wow, Jay, that's badass. Hey, Strop. Mr. Alex, how you doing? Good morning, guys. All right, we're gonna keep our server up here on the left, so we can always see what it really looks like in real time. Uh-oh, uh-oh. I guess we're gonna have to lock this, which is fine. So we'll just do a lock on the back buffer. We're using this across multiple threads, and the graphics object is not so happy about that. Okay, we'll lock there. And there's better ways to do this, by the way, but since this is just a sample test application, it's okay. We can cut corners on a few things. Dumbest you have 3 jobs today? What's the dumbest of your 3 jobs? Let's try that again, guys. So, this is pretty good. Let's see what you guys can see on stream. It probably doesn't look so great on stream, because we get in a lot of packets, so we're doing a lot of clearing. But you can see just how far behind in time this the blue from the red distance. That's essentially 300 milliseconds, right? Because we have a 300 milliseconds playback buffer, and we interpolate over that. So we're always 300 milliseconds behind. But more importantly, what I'm going to now simulate is, how can I get that? Give me a second. I want to think, how can I get that to be a little less flickery for you guys? Because that was pretty flickerific. And it's because we are clearing our back buffer And then writing over the top. Give me a moment. I want to try something. Because I could have two render buffers. Now I'm getting too fancy with this, but it's okay. I'm okay with it. So we can have two back buffers. Go here. And we'll go to our back buffer. So we can render to two independent buffers, and if I keep them transparent, I'm hoping draw image respects transparency and will overlay correctly. And then we'll just lock on ourselves here. And that's all on two. And then up here... Yeah, let's just take a look at this real quick. So... Not exactly what I was looking for. Back buffer. Let me look again. Let me see. Because, so red is not clearing. Which is a little odd. Well, I guess we clear it with transparent, and that's not going to clear anything. And that's kind of our problem. And this, I'm assuming, is going to mean we're not going to draw at all. Oh, I know how we can do this. I know what we can do. Or can we? I'm thinking for a second here. What we could do... Okay, I got it. So we'll clear our back buffer. We will draw first onto our back buffer. We'll do a draw image of our bitmap 2, which holds our real-time information. And then on top of that, we will draw all of our interpolated points. Okay, this will be good. So that means this is fine. We don't need creative graphics here. We don't want to do any, we want to draw, we don't want to do any of that. There we go. All right, let me debug this. Let me make sure, and I'll look at chat. Okay, no, this is perfect now. Is it, though? This is good because we only draw when we have points, and we don't always have a point. I'm gonna look at this a second. Let me take a look at chat here. Oh my god, I want some eggs and bacon right now. Pizza delivery, comp sci tutoring in community college, and app development in ascending order of coolness. Nice, Rob. Nice. Eggs and bacon pizza, that could actually work. That could work. That could work. I could go for that. Excuse me. All right, so why is this still kind of happening? A little bit of an issue for us. Is this a problem with us clearing, and then while we cleared, we're trying to draw to it? Maybe. Possibly. We actually don't need to clear anymore because we're always drawing bitmap 2 on top. And we're just getting in a lot of data. Let's see here. All right, let's see if that lock gets us a little closer. Sorry, I'm getting a little OCD about that flicker, which probably doesn't matter to you guys because of my draw rate. Oh, there we go. Got it. I got it. Okay, so let's see how it looks on stream. So now this is a little better. we could see our blue real-time network, right, object, and then the red is our interpolated network object, so you can see how we are about 300 milliseconds behind in time, and everything's fine. Now, you would look at this, and it's like, well, the blue and the red look identical, right? Blue and the red look identical, so why do we even need to interpolate data in the past? Why don't we just use the real-time network data? Well, this is basically very solid network connection we have right now, because we're on the same PC. Even though we're simulating some standard network settings, it's not. There's not a lot of jitter in here. There's very little packet loss. We're gonna go amp up our simulation on the network to show you what a more degraded connection is gonna look like, and you'll see where red will start winning out over blue. But in this case, blue kind of looks like it's winning, even though on my screen when I see it in real time, I still see blue kind of jump a little bit because it's not being smoothed, whereas red is very smooth, even though that probably doesn't look like it to you guys. But let's go do this. If I can remember where it's at. So right now we are simulating between 100 and 120 milliseconds of ping. So there's not a lot of jitter in there. I'm going to amp up the jitter a bit, but I'm also going to simulate 20% packet loss, which can happen right over larger links. You can spike up to having like 20% to 0% to 5% packet loss and all that fun stuff. Let's see what this gets us. So now this is a lot better. So if you watch, I don't know if you can see it on my stream. I don't know if you can see it on the stream, but the red ball is sometimes able to almost catch up with the blue. And the reason why the red is almost able to catch up with the blue is because we have packet loss going on, so we're not getting all of our snapshots all the time. We have more jitter coming in here, so sometimes the snapshots are delayed, and sometimes they're out of order, so we're losing them in that sense. So there's a lot of network fluctuation going on, where so basically the blue looks like it's moving, then it has to stop, and then it moves, and it has to stop, and then it moves. It's a very horrible user experience to see that. Whereas the red is just constantly and smoothly moving, 300 milliseconds behind blue, but even when blue is stopping like that, red is not. And sometimes red is almost even catching up to blue, but that's okay. What's up, King Recycle? And that's why we are doing interpolation for networked objects. That's the reason. Exciting stuff, I know. And we're actually not clearing we actually need to clear our buffer as well. Let me go do that real quick. I commented it out, and it looks like we might need it. I just want to make sure real quick that we no longer get blue at all for some reason, because I broke something. Why are we losing blue? We lock. Back buffer is clearing right into back buffer. That's why, guys. Sorry. I just found our little bug. Back buffer 2 was a separate graphics object from our bitmap. So we were never ever writing to back bitmap 2. That should solve this. There we go. So now hopefully you can see, right, red's nice, buttery smooth. Blue, on the other hand, very jittery, right? Very stuttery. I think you can even see that on stream, probably. What's up, Rob? How you doing, buddy? Good morning. You just made it? Demonic? I just fooled you all! You ready for the red ball? Alright, guys, let's place your bets. Place your bets. Let's actually fire up another instance of a client and get more balls in here. Whee! You hope red... Is red going to beat blue? You think red can beat blue? I like it. But this is why we simulate, right? This is why we simulate, this is why we interpolate. Alright, well, this was fun. Let's go about getting physics integrated now. All the better for you. Oh my god, Rob, thank you, man. I'm glad you're here too, buddy. I'm glad you're here too. About how they did networking in Age of Empires, very interesting read. Age of Empires networking. That would be interesting. I wonder if they just do a lockstep, deterministic network simulation for Age of Empires. Because Age of Empires, correct me if I'm wrong, I could be wrong, Age of Empires is turn-based, right? Where everyone takes their turn, you gotta wait for the AI to take their turn, and then you could take your next turn, right? So it's essentially a very hard turn-based game, which means it's very easy to do a lockstep deterministic network system. Mysteries, King Recycle. Mysteries of the universe. I'm wrong? Oh, so Age of Empires is real time? Is real time? Well then, if it's real time, I sure hope they're not doing a lockstep. Well, thanks, guys. Apparently, I know nothing about video games. So there you go. So then if it's real time, so it actually gets kind of tricky. So RTSs, when you start talking about like thousands of units, they might actually still be doing a lockstep deterministic network simulation, as long as they can limit the number of players in the simulation. So lockstep networking kind of starts to fall apart after like 4 to maybe you could stretch it out to like 8 players. It gets real rough at that point. Like Warcraft 3. Warcraft 3 and StarCraft and all them. Those are lockstep deterministic network engines. And you know that because have you ever played in a Warcraft 3 game or a StarCraft game online and a player drops from the connection, all of a sudden the entire game freezes and you get a message that says, hey, we're waiting for so-and-so to catch up? Path of Exile uses lockstep, King Recycle. That makes sense for Path of Exile. I could see that. Because Path of Exile, like, what's the maximum number of players that can be in a game? I don't know, Jetty. I know nothing. I know nothing. Thanks for the link, Agenix. I will definitely check that out later. Okay. Physics, guys. Let's talk physics. So we are in the .NET world. Unfortunately, in the .NET world, there are not a lot of good pure physics libraries. Obviously, if we were using, you know, JavaScript or C++ or hell, a lot of other languages, we would just use like Box 2D. About 20 in a town zone. Wow, and they actually got, but it's just players in a town zone. Okay, then you could still get lockstep working. Okay. What was the other library you're using with this? I know one was the networking library, but what was the other one? You're simulating my interest in grabbing at. Oh, you should do it, Rob. You should grab that source code. It's free. We use a few libraries in the project right now. Let's see what I'm trying to remember off the top of my head. Here, all the libraries, by the way, that we are using are cloned in the NBASC GitHub. So if we just go to MBAS, we can see what we're using, right? So we're using Artemis is what you're thinking of, right? So Ligrin is our network library. We use Artemis as our entity entity framework, right? And then that's it. But we're about to add a third library, a third party library, which is going to be our physics system. So as I was saying, what's up, Kill Foo Fun? What's up, buddy? I haven't seen you in a while. World of Warcraft uses Lockstep. Yeah, absolutely. World of Warcraft definitely uses Lockstep. Lockstep was the model, was the networking model to use for a really long time. Original Quake used Lockstep. And they kind of made it work somehow. But that's why original Quake only worked over LANs, and it was very poor over the internet, over dial-up. Oh, they added in the last expansion. Switch to if you if you want it, if you desynced a lot. Oh, interesting. King Recycle. That's cool. That's awesome. So as I was saying, in the .NET world, not a lot of physics libraries out there. So we can't just say, okay, we're going to go integrate Box2D for our 2D world physics, right? And in the 3D world, ODE is kind of the physics system out there. And there, so we have ODE, and and there is an ODE.NET, which is a managed wrapper on top of ODE under the hood, and we'll probably use that when we get to 3D physics, and that's fine. For 2D physics, though, we can't just go grab latest Box2D, because there is no Box2D for .NET. At least nothing that's recent. There's like an old version from 2009. So there's a 6-year-old version port of Box2D to .NET, but I don't want to use that. We're going to actually use the Farseer physics engine. Even though it hasn't been updated in a while, physics engines don't necessarily need continuous updates. Because that's just the nature, right? They're physics systems. They usually are pretty solid. Even Box2D doesn't get updated all that often, and it's one of the more popular 2D open source physics systems out there. Back their Tau map till June for March. Uh-oh, King. Accessible library seems better than something like Stroth because C# is more accessible to the masses of developers out there, I feel, these days. I think, and on top of that, I don't think there is a solid, a good open source server framework for the .NET world. Obviously, if you're using like Unity, right, Unity has its own networking library, even though I don't think it's very good, and it's pretty low level. It's not as complete as we're going to get. So I don't think there's in the .NET world, I don't think there's something like this. So I thought there's a gap missing, so let's go try and fill it. Enderkin's on hold till the beginning of the year. Kill after I move and after we get some stuff sorted out. This is not a game, this is a game engine kill. Game engine, just not a client-side game engine. But we're going to use the Farseer physics engine. This is a .NET engine. It's a native .NET engine, which means it's not just a wrapper on top of some native libraries, right? It's completely managed, which I like. It's a pretty decent .NET engine, and if I believe correctly, Farseer is based off of Box2D initially, and then they made some enhancements on top of it. So it should be very similar. If you've ever used Box2D physics before, I believe it's very similar to that world. And the good thing is there's actually a NuGet package for Farseer. So I want to grab the NuGet package for it and go from there. And we want to get 3.5 is the version we're looking for. Let's see what this does. And I also want to make sure that whatever physics library we install is not dependent on some game rendering framework. There's too many physics libraries out there for some reason that are tightly coupled with like monogame or tightly coupled with XNA, or I don't understand why that is, but it is. ECS and monogame for learning, you know? Nice. Nice, Ginnix. That's good, buddy. Yeah, Jetty, I'm moving. By not client-side game engine, meaning it's a library rather than... So Stroff, it's a library, not an application, but it's for game servers, not for developing rendering clients, right? It's a server-side engine. Obviously, we will have a client-side component because if we have a server, we also need a client for you to integrate in your game to work. But it's a game server library with all the bells and whistles that come along with that. We're gonna get the scripting interface going eventually as well. Maybe we'll plug that in starting tomorrow. Depends on how well we get on the physics side today. All right, so we let's make sure, right? We got our Farseer in here. Make sure there's no problems with good old Farseer. Okay, good. I have no idea, by the way, how to use Farseer, because just like all my streams, it's always way more fun to jump in and learn this stuff along with you guys on new libraries. Remember when we first started using the Ligrin library? That was a little bit of a fun time, right? All right, now I gotta start thinking how we're gonna chop up and integrate physics. So most physics systems, and I believe Farseer is no different than Box 2D in this, right? They're world-based. Typically, you have an island or a world, right? And physics is self-contained, so all the bodies within that world can interact, but they can't interact outside that world. I think I want to implement a similar system, and it's good because it helps you cut down on processing power, right? The more bodies or the larger the world, the harder that the physics have to work to maintain it. So if you can chunk it up and have tight boundaries, and this is game specific, right? But we want to make it generic enough that you can figure out how to integrate physics in your game in the most robust and performant fashion. Series, making a game with it when, oh my god, Stroff. Oh my, that would be awesome. I would come watch your stream. I would come watch that stream. So do I want to integrate this as a system or not as... Well, we should definitely... Oh, thank you for the follow out there. Hikyu Pow! Hikyu Pow! Thank you so much. We should integrate this as a system so that people can reference it via a system. And that's how we'll step it via a system as well. Okay. Sorting it out in my head. So let's just start getting some code down. Yeah, let's start getting some code down. And we're going to call it our 2D physics system, because eventually we will integrate 3D physics as well. Oh, I forgot. What am I doing? Physics system 2D. And as a base system, let's implement that. Do I care about... I will put start and stop in here. Public override bool. At least start, because we want to initialize the world. All right, now at the same time, we got to go back to Farseer. Hopefully there's some simple documentation on how to do it. There we go. So from a physics simulation, I want to support multiple worlds, and we'll support world ID. So first, just real quick, var world equals new world. What can you give? Oh, I don't like that, by the way. Why is that using XNA? I might have to compile my own copy of Farseer. I don't want to use... So hold on, let's see here. Vector 2. It's possible that this is not actually the XNA framework, that they might have just copied via namespacing. And I'm going to go find out. Let's go take a look at the object. Let's browse our object. Let's look at its namespaces. So okay, this is fine. This is not as bad as I was thinking. We don't have to link against the XNA framework or any libraries there. For some reason, they just use that as their namespace. I would prefer that they didn't. But this is, I guess, if you want to interop between Farseer and XNA, right, it's using the same types. So you don't have to do any type of data conversion. But that's okay. Sorry. So we can give it gravity. We can give it. Is that world size? That's a little weird to give it a world size. That is a little odd to give it a world size, but that's fine. Oh, what I really wanted to see though. New vector 2. You always have to give it gravity, I guess. Let's see. Do worlds have identifiers? I'm going to say they don't, and it's fine. We'll wrap our own. Okay, that's good. You playing, oh, maybe I'll even put a death counter. No, don't do it. Don't do it, Screamer. So the physics system is going to be like sort of observer pattern implementation. The world has a collection of entities and notifies them of position changes. Not really, Stroff. So physics systems, you gotta be very careful, right? Because they can be highly performance driven. So an observer pattern over physics like that would not be so good. Obviously collisions or near collisions and that type of stuff are important. And that's more of a callback pattern. Working on a game called Mast, and they hate it when I program stuff for the game. They always like, Charlie, why'd you do it that way? Yeah, but I got it. Yeah, that's right, King Recycle. You got it working. Hey, Ice Masson. Hey, Faith! Yeah, but it's been a while, huh? But I'm back. Okay, so, excuse me. We're going to maintain a dictionary of worlds. And whenever we start, let's make sure we reinitialize our world system here. So now when we tick, we have our delta. We have to be kind of careful here. So most physics systems, you don't want to, you want to be very careful on how you tick your worlds, because here's a good, so for each var world in worlds dot values, here I'll show you why. So we have our world, and is there an update? Is there a tick? Run. All right, hold on. I guess I got to go look at the documentation again. Updating the world. Step. So you want to step your world, right? And we're going to change all our doubles to floats, by the way, today too. We should be using floats, not doubles. Save some performance. Or, yeah. Done it with like libgdx something where it's already done. Well, Strop, it's gonna be fun. Watch, it's gonna be fun to do then. I'm back for Faith. This is my 5th stream this week, if that tells you anything. All Cody's beautiful. Get educated. Oh wow. All right, so. Why would we not just pass in our delta? By the way, this is number of seconds that have passed since the last time tick was called, right? So and that's how we update your physics system, right? It's you keep stepping it with your delta time. However, and that's correct, right? So this is 30 frames per second. Right, or 30 milliseconds, right? So we have 30 frames a second over milliseconds, right? 30 frames, 33 milliseconds a frame. So if we have divided by 33, right? Oops, sorry. Is what we're looking for. And that's in seconds, right? But we don't want to pass in, we don't want to just pass in delta here, because delta can vary. Delta could be 1 millisecond. Delta could be 500 milliseconds. Delta could be any large any range of tick time, because we kind of just run tick as fast as possible. So oftentimes delta or tick will not be 30 milliseconds. Tick could be 5 milliseconds. You don't want to step your physics system every 5 milliseconds. You want a nice fixed time step, right? You want a lockstep physics simulation, essentially. What's up, Faith? Oh, it's okay, Faith. You know how it works, weekdays to weekends. Delta can be a potato. That's right. So we want to convert our delta time here into something that we can run every lockstep, and we'll run our physics, and maybe we'll pass in how often we want to run the physics. Typically, if you run your physics 30 ticks a second, right, or 30 frames a second, you're doing pretty good. That's not bad. But you could also slow it down. You can run physics less often. You'll get less accurate physics. You'll have more bodies intersecting before they pop out. Things like that, right? The faster you can run the physics, or with the more there's other data points we can pass into physics. But we don't want to just use delta directly, because it might not be enough. So we have to write a little bit more code here. So first, let's let's get a step time in here, and let's have a constructor which passes in our step time, and we'll give this a default, right? 30 ticks per second. I don't like saying frames per second in server development, because it's not really frames. This ain't no console. This is not rendering, Kane. This is not rendering. This is physics. The best thing to do is tie physics with your... Oh my god, that's horrible, King. Don't do that. Don't tie your physics to your render frame rate. So we have a step time. Now we need some other data. Floating our own delta time. That's going to... let's just do it right now. And before we're done, we are going... What's the problem here? Yeah, okay. Okay, so this is what we need to do. We're going to keep stepping up delta time plus equal to delta. This will let us accumulate our time here. And obviously it starts at 0, but this will let us accumulate delta time over ticks. Because then we want to say if delta time is less than our step time, we could just return. If we don't have enough accumulated delta time, there's no reason to step the world. But now there's a chance, by the way, where delta is greater than delta time. Maybe we had a hitch here, and now delta is 60 milliseconds. Well, we don't want to step the world just once, because now we're always going to be trying to play catch-up, potentially. And there's another problem with this we'll get to after I finish implementing it. But what we want to do is say, okay, let's see how many times do we need to step the world for our delta time. And we can easily do that with ticks as delta time. Oh, we can't. Can we mod from a... We cannot, so that's fine. So we'll say int ticks is 0, while delta time is greater or equal to step time. We will ticks increase, and delta time is going to get stepped down by step time, right? So how many steps do we have within our delta time, or how many ticks do we have in our accumulated delta time? And this is how many ticks we should step each world by. What would happen if you tie your physics to FPS? If your frame rate dropped to, say, 10 FPS, now you're only going to update physics 10 times a second, and now your physics might not be as accurate as it should be because your frame rate dropped. If you disassociate your physics from your render frames, you can have a smooth physics simulation running no matter what your frame rate is. And it's as King just mentioned, right? If your frame rate spikes, all of a sudden your physics starts running faster. And those are really bad things to happen. You want a nice, smooth physics simulation. All right, so whatever our delta is, we're going to accumulate. As soon as delta time is greater than step time, let's find out. There's at least one tick we can do, right? And we'll see maybe there's multiple ticks we can do in this step. And we'll keep our delta time flowing here. Eventually, this will get back close to 0, and it'll start building back up as we get more ticks in. Why would a big company do that for Fallout 4? Ice Mason, I have no idea. Because they don't want... And it's possible that whatever engine they're using, they implemented that long time ago, and they're just lazy. And if they can lock, especially for consoles... Right, for consoles, you can make shortcuts like that because you can lock your FPS at 60, and you know it's always going to run 60 because it's the same hardware across the board. Then you can do things like that. But if you don't have anything to produce visual interpolations, your frame rate is your physics rate. Hey, what's up, Massey? Massey, oh my God, what's up, my friend? If you don't have anything to produce visual interpolations, your frame rate is your physics rate. Kind of, Massey. So we will, even though we're a server engine and there's no render component, it's still we're still going to have to interpolate a not visual, but a where are you in the world for game logic usage, right? Not to mention we have to ship this simulation, this data to the client across the internet for them to render. I have no idea what I'm doing right now. That's you, Screamer? That's okay, Screamer. Me either. I'm making this up as I go. All right, so we have ticks, and so we want to say for int I 0, I less than our ticks, right? Increment I. And bump up, so step every physics simulation, the number of ticks that we need to. Now, there's a problem with this. At least they lock it at 60 and not 30. King, well, that's true. That's true. That's true. At least they render 60, not 30 frames a second, which a lot of games will lock at 30 for consoles, or back in the day. We have a problem here. There is a chance, using this fixed step system, because we're accumulating time and seeing how many ticks we should execute. If we ever get to a situation where every tick delta is greater than step time, we will never, physics will never ever catch up, right? If our server frame takes longer, a minimum of 30 milliseconds. If it takes longer than our whatever our step time is, every frame, physics is going to have to run multiple steps, and it will never be able to catch up because it's going to have to step one or twice, and then we're going to run again, and more than 30 milliseconds have passed, and even longer because this is not a free computation. This has time to it. So if, eventually each frame is going to take longer and longer and longer and longer to execute because we have to because physics is not able to keep up with our frame rate. Right? That is a real concern with our system here. The only solve, well, there's a couple solves. But the real solve for this is you have to make sure that you give yourself enough of a buffer. So you have to make sure you set your physics tick rate to a number that has enough of headroom that will never happen. So you have to make sure when you're designing your game logic or your game loop that it can run on average at least twice as fast as your physics tick. Which means if we do a 30 frames a second physics step, we need to make sure that the game loop can run on average at about 15 milliseconds, right? Can't you run physics on its own thread? You can, but that still doesn't solve the problem. Because you can't. It gets tough when you want to run physics on a separate thread. Because remember, physics is just updating our positioning and our states in the world. At some point, you have to then render that physics, right? So you have to know where in the world they are. So then you have to do some type of synchronization or lock across your threads to go say, okay, where am I right this second in the world? And then, of course, smooth that into a visual pixel location. And that gets real tricky when you're trying to do a multi-threaded physics system. And not all physics engines are designed to be multi-threaded like that. But you still have a problem where... yeah, you basically can't identify things like that, right? Because then you get desynchronization happening at that point. So it's not very common where you'll see physics run on its own thread. You could do it. You could do it. There's you got to put a lot of work into it. So we are going to just make sure that in our system that our game heartbeat is able to be twice as fast as our physics step. And that's usually enough headroom that you're not going to run into problems, right? And it has to be on average, that your heartbeat. Okay. We need to go update our system and get... what? Thanks for the host, Recycle. Thank you, sir. Okay, so... we need to go update our system to use floats over doubles, by the way. We were hacking some stuff up the other day, and we haven't gone back to change it. For instance, right, we want to make sure that's there. There's a few places we have to go update, not so crazy. This is going to increase our errors now across the board here, but that's okay. Okay, give me a few minutes to go fix everything up. Double float, jeez. Jeezy Priestley. I should just look for all ticks. I should just do a find and replace on this. But there's only a couple more, so... I'll just do it by hand. And now, okay, good. This, we need to do a hard cast down the float from our timer. This will be okay. We lose a little precision, of course, but the precision we lost is probably not going to be felt because a float precision is way more than enough for a high accuracy in timers. This now needs to get floated out as well, and that will fix us. And there we go. Is that it's a partial what? Is chat teaching me stuff? Nice, King, nice. I like it. I like it. I like it. All right. Back to physics. Back to physics, because we actually haven't implemented any physics, right? We updated our tick. We have a wrapper around some stuff, but we still need to be able to create worlds. We still need to be able to add bodies to entities, all that fun stuff. And we got to integrate this with our entity component system. Hey, Chocolate Cake. What are we making right now? You're pretty new to programming. Well, man, I'm glad you're new to programming. Stick around. One day, you will be old to programming. What are we making right now? We're working on an open source, real-time networking game library. exciting stuff that has very little visual appeal. They use our release. That's so weird, Kane. I wonder why they're doing that. How can I find me on Facebook? You cannot find me on Facebook. But you can find me on Twitter. What's up, pizza? Okay. First, let's just start getting some stuff in here. Right? We need a way to create a world. And we'll return the world. Or do we ever want to return the world? Or do we just want to deal with... Because from a consumer side, I don't care about worlds. I care about world IDs. I care about world IDs. Okay, so I want to add a world. Actually, it's called create world. And ID. You can pass in an ID. If you don't, we will create one for you. So if ID is 0, ID is going to be the new... Actually, we're not going to let you define, because that won't work, to tell you the truth. It would be a little weird. We'd have to go find an unused world ID in our dictionary, and I don't want to do that. So you cannot create no world IDs, and I don't think you really need to anyway. So create a world, var world. Let's actually go create. Let's pass in a vector 2. Do we want to start using vector 2? We might as well start exposing vector 2s, right? Gravity. New world of gravity, and then worlds of ID is world. And then return the ID in case you want to use it right away and don't want to go look it up. Master race, 300 frames a second. Oh my god, I like it. Let's also have a means to delete a world. And this takes in an ID. Alright, so we're just going to go look it up and grab it at the same time from our dictionary. If our worlds try get value of ID out of our world, out of our minds. If it's found, that's great. I just don't know. Let's see, is there... I don't think there's any clear... I'm going to clear forces. I just want to make sure it gets cleaned up ahead of time. It'd be great if this implemented iDisposable in a proper .NET fashion, but it doesn't. Because you can't actually delete the world. We can just free it so that garbage collection can handle it at some point. But I'm hoping this will kickstart us a little bit. And then worlds, remove. We actually need to make this thread safe. So that's going to be a try remove of ID out world. And return that, otherwise return false because you gave us a bad ID. That's why manual management is best. Well, okay. It is best, sure. I don't think anyone can really argue that in that sense. Public. Okay. So we have a world. We can add a world. We can create a world. We need to be able to work with. We need to be able to work with bodies within this world. I'm thinking that we should implement this as an entity component system as well, so that if somebody takes an entity and they attach a physics component, it'll instantly just pop into. I'm going to do that. I like that. I like that idea quite a bit, to tell you the truth. And in that way, this is going to move into here then. And we got to make just a small little tweak. Oh, and we should, I need to create a component here. Add a class. This is a physics 2D component. Thank you for the follow out there. I appreciate that, guys. A component. Okay, just to get that started, we'll start filling that in shortly. Back to our physics system. It's no longer base system, and we just have to implement the interface directly. And okay, let's make sure we implement what we're missing here. We'll get the entity manager, we have start, we have tick, and stop, we don't do anything. We'll get entity manager in a moment, but more importantly, this has to be of a physics, what do I call it? Physics 2D component, right? Okay. Okay. And implement that now. This is not an override anymore. That's not an override anymore. We're not going to do anything in process. Actually, so I don't even need to override that. But I do want to protected override. No. That's public override. Public override on added. And then we say var p component, the physics component is our entity.get component, our physics 2D components. If I can spell today. If p component not equal to null, we'll do some work on it. On remove gets a little more complex, so I gotta do some state management there. Hey Rex Mix, how you doing, buddy? How you doing? Is the sun popping up on me, guys? Sorry about that. Hold on, let me see if I can adjust that a little bit. Oh my god, that sun is just like, boom, right in my face. I think I fixed it a little bit. Sorry about that, guys. Maybe not. Maybe if I stay like this. The sun is coming up. Where is it coming up from? Hold on. I should, let me fix this. Let me see if I can fix this. We're enjoying ourselves this morning, guys. Apparently this is out of alignment. And I don't think I'm probably making it worse as I go here. Maybe a little better? That might be a little better. Let's see. Sorry about that, guys. Turn off the sun. Yeah, get that sun out of here. All right, hold on. I'm just gonna wait for the stream to update and see if it's a little better. It's not perfect, but it is a little better. And it will go away. It'll go away very shortly, by the way. Obviously, it's very early in the morning here, and the sun's just coming up. All right, we're just gonna live with it. So we have our physics component. We will do some work with that. What else what am I missing here? Oh, that's right. It's abstract. We actually have to implement this, even though we're not going to do anything with it. And public override void on remove. One thing I don't like about on remove here is we cannot go get the component that just got removed, or physics component that just got removed. It kind of irks me a little bit that is implemented that way. It don't get more exciting than that, Screamer. This is that day. In your chat, I don't see. Oh, Rexim. I dual stream to both live coding TV and Twitch at the same time, and then I merge the chat on my stream so everyone can see what everyone's saying. So the guy, when you're seeing somebody in green, it's from Twitch. If you see someone in yellow, it's from Live Coding TV. Watch wherever you want to watch. I make myself accessible. I should be about the perfect amount, Wigor? Nice. All right, our component here. We need to set up some, so in entity component systems, it's all about data driven, right? We're not gonna have like a physics object. Instead, we have a physics 2D component. This is gonna hold all of the physics lookup data that we need to interop with the physics system in and out, right? So obviously, the first thing that a physics object needs is what world it's in. So that would be a world ID. What world's it in, or what world should it get added to? Right? So in our physics system, since we are calling on added and we have that, we can get the world ID, right? pcomp world ID. We can go look up that world. Var world equals get. I'm going to make this an internal. And the reason I'm making it internal, not private, is while I don't want consumers of the library getting the world object directly themselves, internally, other systems might want to access the world directly if we want to make it easy for them. So that's why I'm making it internal, not private. And then we're just going to do a worlds try get value ID out of our mine and just return it. It'll be null, by the way, since this is an object. If it's not found, they will set world to null. So we just have to check that, right? So now we can go get world of our world ID if world is not equal to null. Now we can go build a physics body for this. Oops. And bind it up. Excuse me. Okay, so var body is world.create. Create body. Wow. Where are you at? Oh, it's called add body now. Is that right? I don't want to add a breakable body. Isn't that what I'm supposed to do? I want to add a body. I don't think I want to add a body this way. Oh, maybe this, documentation might be a little out of date. So you pass in a world that way. That's a little odd because that's not going to use connection pooling. You know, let's go take a look at the source code. Let's go see what's going on there. It's an aggregated chat. That's right, Mixon. All right, we're waiting for Codeplex to load. This will be exciting. Let's see, where will we find? Maybe under dynamics we'll find bodies. So the problem is this is going to instantiate a new body. And this is just called world.add body. Bodies can't live without a world. Of course they cannot. But you would think they would... that's a body stack? Interesting. You think they would have a pooling ability of bodies, but I guess not. Maybe not. We could always implement our own, too. We can add our own body pool. Whoa. Let's add a body pool. Let's do it. I'm just looking through this real quick. I don't see anything exciting. Joints and fun stuff like that. Oh, it's clear. Remove all our bodies. Good. Okay, so clear does what I was hoping it would. All right, looks like this is the only way to add bodies. That's fine. And we're Do we want to give it initial positions? It's actually a pretty good idea, by the way, to when you're creating bodies in physics systems, if you know what their position, rotation, and blah blah blah. See how it says a user data? We're gonna bind that user data to our entity, by the way. So for now, let's see, null, 0 rotation. User data, though, is going to be our entity. So that's how we're going to be able to do a lookup back and forth. So when we do an on remove, I'm going to go find the body that has the user data of our entity, and then we can make sure we remove that body from the physics simulation. Okay, so that gives us a new body. Body is added. Let's get the remove going here. Oh God, I don't know what world this entity lives in, and I don't want to go through all worlds. That's kind of harsh. I really wish I could just get the. Yeah, you know what? Let's take a look at something. We're gonna go look at Artemis. I want to see why they don't like me. Why don't they like me? So when we do on remove from a system, because we use a entity processing system on. Okay, apparently this is just implementing a entity system. Okay. So on, ooh, this is public virtual on change. We could do it from on change, and I think maybe get, I don't know, let's find out. So this just calls remove. So we're going to remove the system bit from us. If it's enabled, disable it. And then we just call on remove, right? The problem... Okay, this asset intersects our entity. If aspects intersects, what's our aspect? I want to see how aspect is built. Aspect is empty. When we can give it an aspect, and that's probably what's happening when we do it from as a template. It's going to do an aspect of 1. All right. So if it intersects, it just means, does this entity have that type? So if it's interest, all right. So if we're part of our system bit and it no longer intersects, that means the component has already been removed. And that's what I don't like about Artemis, by the way, is because we don't get back that data. I'm alive, Cornflower. What's up, buddy? With the body stored in the pool? Oh my god. Oh my god. What's up? What's an interval system here? Oh, it just does timer, reached, delta, then we enable. Oh, interesting. Okay. There's a queue processing system. I guess this stuff just gets queued up. And when we process from the queue. Kind of interesting there. Okay. This, by the way, queue processing system, this is how you would make sure that this processor doesn't use over X resources a game frame, because you say only process 50 entities every frame. If there's more than 50 entities in the frame, then oh well, you're gonna have to wait till next frame to try and catch up. I've been good, Cornflower. I've been good, buddy. What's a delayed entity system? I'm just looking at all their weird entity systems. Looks like it will run everything on a delay. Okay. And there's a... I don't know what the tag system is. Any events in the event system. So we have an entity. We can use tags. I don't like that, though. Oh, you know what? Ooh. But then that's... No, I don't want to do that. Sorry. I was thinking of something. That's not a good idea. This comes in. Let's go for our manager. We want our... Where are you? What am I looking for? I'm looking for an entity, which is going to be somewhere in here. Maybe under... Not utils. Not in system. There's entity. Wow. I want to see how it works when we remove... we remove a component, right? So it goes from the entity manager, remove component, this to the type. Or you can give it the component type. All right, so let's go to the manager, entity manager, remove components. Calls into here. So it just adds, excuse me, components to remove. We get the pair. For each pair in our index. Grabs the components by the ID. So this is going to be this removed component event. That's what I want to find. And then it's going to remove the bit. And it's going to refresh the entity, which calls the on change. What is this? Let's search the whole code base for this. Maybe this is an event that we could register with to get what we're looking for. Got to go to the real code base. So that is... Oh, there's two places that happen. Test general. So in the entity manager... Okay, let's take a look. It adds this entity remove. And this is in the entity manager. That doesn't help us at all. Looks like this is just used internally. Because I want to get that copy of the I component. So we're going to find it's just going to add it back to the pool. That's all they use it for. Oh, but we can register with this. We could register with this though. I think. Let's see if that'll work. Okay, hold on. Because we actually need to get the energy manager. Excuse me. Return this dot entity manager do no, not sorry. Not. I'm trying to remember how. All right, let me go look at the other one. How did we do this on the player system? Entity world.energy manager. That's what it's looking for. But more importantly, in our when we instantiate entity world, we are just entity manager dot remove. Was it remove entity event? No, I don't want to not remove entity. Remove component event. So this gives us our data. And this is before the bit happens. We'll have to test this, but I think I can just get, let's see, var p. This is, by the way, we got to be very careful with this. This is all entities in the entire system, not just physics components. Not just physics components. What's up, Danny B Games? I've been around, but I'm back to streaming now. My name is not a reference to Flyka. What? Oh, oh, yeah. So we got to be careful here because this is all entities in the entire world. But that is okay because every time we remove one, we just want to say, hey, get our component of physics 2D component. If P, and actually, what is a component? It's an I component. We can just do this cast right here. P comp is this would be faster. Component as a 2D, as a physics 2D component. If pcomp is not equal to null, then we know it's been removed, and then we don't actually have to override this. This is a funky way that we have to do this, but unfortunately that's what Artemis gives us, so okay. Alright, so now we can say var world is equal to get world of pcomp dot world ID. If we found a world, now we have to go find the body, and we should, you know what, I'm going to do a lookup here. Go to definition. We don't necessarily have, no, I don't want to, actually I do, I'm going to. Public body, body. So this would be a two-way lookup, and it's, just give us a little enhancement here. If pcomp.body not equal to null, then we can go world.remove body of body, and then pcomp.body is null. What doesn't it like here? Of course. And there we go. That should make sure we stay clean. You've been missing it, Danny B? I've been missing it too. For parts for an S big build. No problem, Danny B. Come back whenever, buddy. You come back whenever. Alright, so let's move this down so we can region this up. Region component system. Don't have to look at this ever again. I was just thinking of something. I'm gonna go make a change. We actually want to make this an internal set. I don't want, you should never try and set the body. You should only try and access the body. And more importantly, well, this will let you do whatever you want against the physics system, right? So you can use this to access the current position of your entity in the world. You can use it to override their position. So this is our, apparently, essentially, this is our proxy hook into the physics system from a component level. This will let you set forces, all that fun stuff. But we don't have a means of initializing, so I think I'm gonna have to do that. Vector 2, starting position, get set. Vector 2, yep. Starting velocity. I gotta give initials because we have to, because there's no other way to do this, and it'd be really hard to create a new physics body and wait a whole game step before it gets added, before you then actually get a real body reference. It would be horrible. Hey, Summit. What am I working on? We're working on a real-time, open source game engine. We need a few more things here. Maybe let's just start with this. Because we gotta add, we need to get angle in here and angular velocity, right? A couple other starter data, and oh my god, actually, it's gonna get more complex. Because what if I want? Because obviously a body is one thing. But what if I want to also set up the collision data and joints and stuff like that? So that's gonna keep expanding, but that's okay. We'll do it as we go. So we're gonna create a new body. And remember how we had position? Well, that's going to be pcomp dot starting position. And we don't have rotation right now. And then we'll just say body dot... we should not be... Sorry. I don't know why I did that. Was the thinking ahead of time? There is no such thing as starting. We don't want a starting velocity. You got to get your body into the system, and then you can start affecting forces on it. But that'll give us a starting position. Okay, I kind of want to start using what we have so far in our game, because remember we have a and that means I can get rid of our... We have another entity in here, or do we not? What did I do with it? That's in our move server. I'm going to be able to get rid of some entities in our move server. We don't need the mover system. This was our old, very simple physics step system. We're going to get rid of this. Don't need that anymore. What happened? Enderkin is still around. We'll be back working on it about the beginning of the year or so. And then it'll be all good from there. Okay. So we don't need that, which means we also don't need... well, we need move data. Because move data is our network packet, essentially, that we send over the wire. But, or do we actually... We actually don't need this anymore. I'm going to get rid of move data as well. Okay, let's just go do it. Let's go to our move server. Oh, sorry. I'm not done yet. Well, we need to instantiate this. We create our entity world, we load our config. That's in run. We want to start everything up. Where do I create this at? There it is. In load config. Yeah, this would be a good place for this. Then we want to say var 2D physics, and this is where config will come in, because then you'll configure, do you want to configure for 2D or 3D physics or both, for if you want to use both, but that's okay. New physics 2D system. We got to give it a step time. We're going to use the defaults, and I'm going to fix our step soon too. So that's our physics. Let's add that in. So add internal system of physics. Physics. That's all we needed to do, because now I can go over to the move server, and when somebody logs in, right now we are, we create a player entity, right? And then we're adding our move data component. We're not going to do that anymore. Instead, I want to, I got to create a world, sorry. On start, set that up. Var physics system is equal to lookup system of our physics 2D. And then physics system dot create world of a vector 2 of 0 float and a 0.98 float, right? We'll give it actually, I'm not going to give it any gravity. We don't want gravity in our simulation here. And yeah, that's we need to add a reference to Farseer. For now, that's fine. We're gonna do some refactoring there. That means I'm gonna have to wrap some stuff up. Sorry. Go ahead. Well, I don't want to do that. New. There we go. Okay, so that's going to create our world. I just want to store that int world ID. So we're just gonna use one world for our system. All right, so now when they log in, we can just do var phys data equals new physics 2D component. What did I call that? Not physics system. Thank you for the follow out there. Physics 2D component. Yes, please. Why does it have a... What did I just do here? Hold up. Apparently I can't remember what I named things. I can't remember them. So we just want to... so we're an entity component system, right? Which means we don't create a physics body. Instead, we create a physics component and we attach it to our entity. And now this entity will participate in the physics system. That's what we're trying to do. Then phys, thank you. What we need to set up here is we need to set the world ID that this is going to exist in. We need to give it a starting position, which would be a new vector of 0, 0. And I want to give it some velocity, but we'll get to that in a moment. I wonder how I'm going to do that. We'll get to it. Because I can't give it a starting velocity here, right? Because we kind of got rid of that. Phys data dot, and maybe I should put that. You know what? I think I might just go put that back for now. But that doesn't make any sense in a physics world, in a physics type world. No, we won't do it. So that's all we need to do. And then player entity, right? We want to add a component of our phys data. No longer are we going to use our move data system. So that's great. However, on our snapshot, we don't want to get move data components anymore. I mean, we're still going to use move data because that's our packet that we send over the wire. That's our data point, but we need to build those differently. Instead, what I want to do is get a physics 2D component and say var phys comp, and then if phys comp not equal to null, create a new move data, var move data equals new move data, and then set our data to set over the packet, right? So x is equal to, and this is the only data we really need to set. I need to move velocities out of there. Physcomp.body dot position of x and y, and we're gonna we have a whole bunch of updating we got to do here, and that will send that over. Why can't I? Oh, that's right. And we don't care about velocity, and these are going to be floats as well because I'm going to go change move data. All right, so that will set our ID. That'll set up the data here. Hey, 70 nights. Hello, thank you so much. Oh, I don't know what was that sound. Uh-oh. Uh-oh, okay, so it looks like that's gonna be that. But we should still be fine. I wanna make sure. Let me know if the streaming stops, guys. I think streaming will go. That's a fun little OBS error. I just wanna make sure I'm not stopped. Okay. Let's go update move data now. All right, so essentially what this is doing, we've added our physics, we've added our player entity into the physics world. We're not giving them any necessarily stats right now. We'll do that. Is sound out of sync? How out of sync is it? Is it really bad? All right, we're gonna pause here to make sure we can get the stream set up correctly. I'm just waiting for confirmation if it's really bad out of sync. Okay. All right, guys. I'm going to just bounce. So don't go anywhere. I'm going to bounce the stream 3 seconds before. Oh, my God. That's pretty bad. Okay, guys. I'm going to bounce the stream just real quick. The stream will be down probably 10 seconds, but then it'll be right back up, okay? So don't go anywhere. 1 more second. It's Godzilla? Okay, streamer. And we're back. Hopefully we're back out there. Can you guys hear me out there in TV land? Hopefully that bounce was not too bad. Just hit F5 out there. Let everyone know F5. Sorry about that, guys. I'm going to have to do some work here, I guess, on figuring this out. For some reason, OBS wants to crash on me. And about at the 2-hour mark, maybe. So we'll see how that goes. Much better, guys? Much better. Okay, thanks. It's working all right. At least, guys, this is better than before when the whole, my whole encoding PC would crash and it'd be like 2 minutes before the stream could get back up, right? The current version on GitHub won't compile missing player and part of the product. Can you add them? Yes, sir. Thanks, Rob. I will do a check-in here real shortly, Rob, and we'll make sure it's all cleaned up. Thanks for the heads up, buddy. I don't know. Oh, Visual Studio must have messed up and not added it in the commit. But we'll get it there. So, as I was saying, we're adding our player into the physics world. It's going to start interacting in the physics world, and that's cool. We need to... You did, Rob. Perfect. Now, whenever we send a snapshot, we want to go get the current physics data and bundle that into our snapshot to send down to the client so the client can simulate what the server is seeing, right? That's what we want to do. And that's what this is going on. But now we have to go change some more doubles right into floats. And this will cut down. This is going to cut our data size in half, by the way, because we were sending doubles before. We don't need to send doubles for this type of data. Floats, precision of floats is more than enough for our physics simulation. In general. Obviously, you could start getting some weird rounding errors if you're doing a ton of float math. All right, this is definitely going to fail in a few places. So this is when we're sending our snapshot data, and we need to go implement a float handler here. Okay, public float, read floats, return buffer, read floats, click void write a float as well. Okay, so that's updated. These should be all read floats. And more importantly, when we write, they're already floats and the write will work. Okay. We're just going to delete this system. We don't need it anymore. So mover system gone. Let's see where that gets us. Remove, we don't need that. And this should be position.x and position.y. There we go. All right, I'll compile. Not going to necessarily work yet, but I'll compile. I need to go to our client because we don't have this in a common library for our test harness. In a real world, should probably have it in a common client. Our snapshot packet is reading read float, read float, read float, read float. And I actually don't care about serialization. I'm actually just going to remove this. We don't serialize on the client, we just deserialize. Right, that's the only logic we need. Is that correct? Yeah, and I'm going to remove deserialization on the server because we don't deserialize at the server. You know, I think we could try and run this. We're not going to be moving. I just want to make sure I have no crazy issues going on. Break. So there is our first crazy issue, right? Why don't we have an entity world? Oh, because it's in our constructor. And our constructor. Excuse me. I need to look at something. How did we... I can't do this in the... This basically can't happen in the constructor. We'll put it in start. The constructor that's not been bound up, we don't have an entity world in it. Because remember, we're a derived class, and it's the base class that is... And the base class constructor gets called after our derived class constructor. Not helping. All restart should have checked before I sent. What are you talking about, Rob? What do you mean a browser refresh not working? I could use Style Cop. I hate Style Cop, dude. Hey, Andy, it's going well. I hate Style Cop. You can't manually call the base class constructor manually. It's a good question. I don't believe so, because that's how you would call it in no, right? The derived has to be called before the base. Oh, Rob, and then everything crashed. Sorry, Rob. Yes, I will get that fixed up in our next check-in, which will happen here very shortly. I will definitely get it fixed up so it can get compiled. All right, let's see if this is working now. Of course it's not, because this is not initialized. You gotta love it when fun stuff happens. It helps if we set data up, right? Enkin Steeman, that will, I gotta think, it's real early in the morning, I've only had one cup of coffee. You are correct. That will call it first. Yes, that will call it first. Yeah, you're right. But that's okay. Where is this being called from? Why do we still not have... Oh, my bad. My bad on this one. On that second error. That's all on me. It needs to be a... not an add internal system. Where's our system at? It needs an entity system. But that's gonna fail, so I need to manually do it that way, okay. Because I want the run order to be... Actually, the default run order for this is fine. I closed it. I closed it, didn't I? Yeah, I just can't do add internal. This needs to be an add entity system. And that will bind it. Well, that should have bound it. It should have, even though we don't have an entity world yet, because I'm still doing things poorly. In load config, is this because I need to move something up in our entity world? Equals. So this needs to happen before we load config. Okay, server up and running. Let's just make sure the client works. It should just be at 0, 0, unless something really wrong. Okay, that's not good. I don't have... Oh, let's... I should probably have debugged, because we just added this, our physics system. Right, to make sure that on add is getting called, if on remove is being called, what's happening there. And this makes a lot of sense because I create the body, but I don't set the body so that we get our proper two-way lookup. Right on. WPF is pretty awesome. WPF is pretty awesome. Alright, so here's component. We're going to add it. We get our world ID. Should that be... Yeah, 0 is our first world. That's... Oh, nope, that's not good. Do we actually have any worlds? Where is my worlds? We do not have a world. Why do we not have a world? Why am I not surprised? Alright, I am surprised. Didn't we add a world? Didn't we do this? Are we not calling... No, that should definitely be getting called. Our move server. We add our move... We add our player server. We never add ourselves as a system. Add system of move server. This. So there we go. All right, we can get the physics system now. We can create a world that hopefully worked. We have a world, that's fine. Entity, what am I looking for? On our physics system. We have a world now. We have a world! Okay. And let's make sure this is gonna work now. We get back our world. We're able to create a body. Yay, our starting position, that's fine. We don't set one. And the server, oh, we have to update our server renderer, by the way, but right, that's where we should be rendering because we're not moving it in the physics world right now. Cool. Okie dokie, artichoke. And what's up, Ketsun? I've been using Unity, game engine said, so no, oh, right. Oh, I hate tonic water. So, more for you. More for you. More tonic water for you, man. On our server, we have our little render system here. But we process move data, which is not correct anymore. We should be processing physics 2D components. We should be processing these. Right, and we'll get physics components, and then that should be position. Oh, sorry, body.position.x. And we got to be careful here because body might not exist yet in multi-threading, so we'll just do a check. If components 1.body is null, return. But now, server should start rendering as well. Client, server, okay, good. Okay, that's fine in that error. Oh, I wanna be. It's best with vodka? Oh my god. It is best with the vodka. Okay, so how are we gonna get this sucker moving, by the way? I think I'm gonna cheat. I'm gonna do a little cheating here in our test. Because normally we would have game logic running, right? You know, we have a physics system and that's great. We're not defining any physics collisions or things like that right now, but that's okay. I just want to get our body kind of moving. And then we'll get some collisions in there and see how things bounce off of each other, right? We'll get colliders going. But more importantly, in a normal game, you would have some game logic system that's applying forces when they need to, right? When something needs to move, it's going to go grab the physics component off the entity, and it's going to say add impulse velocity or set velocity or whatever it's going to do. We don't have that in our test move server. I'm going to use the render system to do that because the render system is already processing physics components to render. So don't mind me when I do weird stuff like this in just our test, right? I want to see how do we actually... I know how to draw. That's great. Oh, this is how you create... So this is how you can use... I think we're going to refactor our body creation into this, by the way. Because this, hopefully, will use object pooling. How do you apply forces? Do we apply directly to the body? Or do we need data for that? Well, let's find out. Component 1 body dot let's see. We can get linear velocity. Let's just see what happens if we set linear velocity of x is going to be equal to 10. Is this just a getter? Cannot modify the return value of body because it's not a variable. That's fine. So far body equals component 1 dot body. Body dot linear. This is a getter setter. Okay, x is equal to 10. Is this a... Hold on, let me check something here, guys. This is a struct. So obviously we can't just... so we have to set a new... There's no equals on this. That would get us... I want to know... I'm just trying to figure out how to add velocity in this system. Because I can get linear velocity from points. Okay. We could just update the position with this. All right, let's try it. Let's see. Velocity equals new vector of x, right? 10 and 10. That's fine. Let's see what happens. I just want to see if this gets it moving, if this is the way to set velocity or not. All we have to do is connect a client, and that will get the server moving. Actually, we'll get everything moving, right? If I did things correctly. Uh-oh. Are we moving? We might be moving. We are moving. 10 is very slow, apparently. So right now we're moving 10 meters per second. And apparently 10 meters per second in our world. No, we should be moving really fast. We're not moving at all. What am I talking about? Just to make sure, right? Our current linear velocity, let's set that. Whoa. Why did that not change? So it's 0, right? Body linear velocity, 0, 0. We got body linear velocity is not updating. I'm a little freaked right now. I just want to make sure that this is working correctly here. And what that's doing. Alright, let's see what the heck. Let's see what the heck. Client, server, client, yet. Okay, so we have a velocity of 10, 10. And that does not update our linear velocity. That means they have a getter or setter logic. We're going to go look at the code for that. You know what? Let's just go do it right now. Because that's freaking me out. So we have the code here, right? Let's go look at body. Velocity. Oh, I should probably give it a... I wonder what's the default body type is. Static. May manually move. Note, even static bodies have mass. Non-zero. Right. Kinetic and dynamic. This is determined by... Okay, so we're a static body by default. It would look like, I'm going to hope. And that's good for us. So there's an internal linear velocity. So here's the getter and setter, right? So get always returns linear velocity. Set, oh, look at that. You can't set velocity on static. All you can do is update their position. And that makes sense, actually. So this is something we need to add in to our component. Public, what's it called? Let's see. That's body type, right? Body type. A body type. Get and set. Now in our move server, when I create on login, data.body type is going to be dynamic. One more change we have to make real quick at the physics system level. And we're, oh yeah, that's right, var body equals new body factory. Not new. Body factory dot create a body. You give it our world. Give it, we want some more data. Our position. And we can give it rotation of 0, and then entity is what we want to attach it to. So that's our body, and then we want to say body.body type is equal to pcomp.body type. All right, let's see what this does now. This might be moving too fast, might be moving too slow. Hopefully it moves a little bit. So there, all right, setting our velocity now. And now we're moving, right? Now we're moving. Oh, we're not going to bounce off anything, by the way, but we are definitely moving. And we've moved away from our manual mover system into an actual physics solver, and that's pretty cool. If you can see on the right how close these are together because how slow it's moving, the faster it moves, right, the further apart these two variables are going to get. And we're just going to move off screen and nothing's going to happen. There is a we need to figure out how we can get some bounding boxes in here. So now we need to see how can we add colliders and shapes and stuff like that to bodies. What's the blue dot? Oh, so the red dot, so the blue dot is the raw data coming in over the network. So it's the latest snapshot packet we get from the server. The red dot is our interpreted, simulated position. So it's the smooth position. But in order to do that, it has to be done in the past. And we do it over a 300 millisecond buffer. We're going to cut that down to 100 milliseconds soon. In your spare time, I love it, Rob. So that's what. So I like to. I'm rendering real time versus interpolated time. So you can see that real time is further ahead, but it's very jerky because of packet loss and jitter and things like that. Whereas the red dot, very smooth, but obviously it's going to have to run in the past. But as long as everybody connected to that server is running the same time in the past, it's a fair playing field. Back to here. I think it had a simple, like, floor, or let me check something. No. I don't care about any of that. We might just have to make this ourselves. Let's do it, Jacob. You know what? Let's actually commit all this to GitHub real quick. So so Rob over there can have some fun on his own. Let's stage everything. All right, so Rob, what was missing? You said player Player system was missing. There was a few things that were missing, right? This should be good. All right, Rob, let me make sure this pushes correctly. Let me know if the latest repo is working, Rob. And if it's not, let me know it's broken, and we can definitely go fix it, because I want to make sure the repository is not broken. Okay, and understand, of course, Rob, there's still some hacky stuff going on that we're going to be fixing over the day here, right? Doing some fun fixing today. Okay. How do we now get view shape and then oh, sorry. So typically how we would do like bounding boxes on our screen essentially is we would need to create a body, maybe one body, and then we would need to add a 4 shapes to it and fixtures to it, right? So we'd have 2 line shapes or small rectangular shapes or whatever. We don't need joints right now. So I'm just seeing how I want to make that happen. How am I just going to expose Farseer directly? The game can't be too reflex. Yes, it can. Kill. Yes, it can. Oh my God. What's up, Ryzen? What's up, Ryzen? Hey, Ryzen, you gonna play later today? You in for our Warcraft 3 action? So I gotta ask a personal question for off stream, but he's in my stream right now, so I gotta ask him. No, so that's not true, Kill. That's not true. You can definitely do a reflex dependent, and this is how most games work, even, right? The player you're controlling will not be in the past. You'll obviously be controlling them in the now, but we'll have systems to smooth them over if they get too far out of sync. But more importantly, it's the server that knows how far ahead a client is from the simulation, and they can back up and replay commands as needed to validate that things actually happened when they did. Two things from player system play. I think those are now there, Rob. Yeah. Time to come back. It's a stream time for you. It's all good, Ryzen. It's all good. You're just gonna miss out on all the fun. That's all. All right. What the heck were we gonna go do this? Oh, I want to figure out how am I gonna do fixtures and shapes. Oh my God, we play a lot of Hungry Hellhound, and we play a lot of Warlocks. The only thing you should be doing with Warcraft 3 these days. Yeah. Two balls and connect them. Yeah, that's fine. So we only really need one fixture, and then you can have multiple shapes on that fixture, and it's typically the shapes that are the colliders. But you can have multiple. I don't want to limit the physics system. Is essentially what I'm trying to get to here. So and we're already kind of exposing. Which means I should just expose the Git world and let them get back their whole world to set up everything they knew. Where the player sees himself behind a wall, but others can shoot him for 100 milliseconds longer. No, not really, Kill, right? So obviously, by the way, Kill, no system out there is perfect. Networking simulations is all about bullshitting, right? That's all it is. It's about who can bullshit the best. It's all about who can bullshit the best. But it's up to the server to reconcile those type of situations, right? The server knows that player A, their ping is 100 milliseconds. So they know where they should be when movements are coming in the server's master simulation, and it knows where player B is, and it just has to make that, it has to synchronize that. Now, obviously, if you're running like 500 or 1,000 milliseconds behind the server, that's when things start to look very desynchronized. But at 100 milliseconds, it's not so bad. Yep, okay. Let's just expose it. Otherwise, we're going to end up spending so much time trying to encapsulate the physics library and end up writing so much code that it's not really worth it. Why are we trying to hide the physics library? And we actually already have a function for this. We just marked it internal right now, right? We can get a world by an ID. So this is now just going to be public. So on our server, for instance, we are not here in our move server. I want to set up some stuff. In start, right, we create a world. Var world now is equal to physics system.get world of our world ID. Entity equals bounding box entity is equal to new new entity. Is that right? Yes. So I want to create a bounding box entity, and we can make helpers for some of this stuff, by the way. I don't know why I just did that. We can definitely make helpers for stuff like this. Because you're about to see the code I'm going to have to write to make this happen. I'm trying to remember how to create an entity. We got to get it from the world, which we can get from the physics system entity manager create a new blank entity, right? We don't need an ID. I need to load up a var physics comp is new physics component 2D physics comp dot starting position. We don't need to set a starting position. Physics comp. We do want to set a body type to be static. It's not going to move, right? We just want to set up a bounding box. Hey, Decker, using Artemis? Yes, I am. And what physics engine do you use? Farseer? Yep. No, we're using Farseer, Decker. Okay, so component static, great, right? Bound box entity. We want to then add our component to it, and this will add it into the physics simulation. Which unfortunately does mean we don't have a body yet to attach what we need to, and that's unfortunate because this has to go through a tick step. And remember when I said I want to set up fixtures, so I think this is where we have to set up how we want to create fixtures and then attach them to bodies. What's up, Serial Popo? Thanks, man. It's good to be back, right? It's definitely good to be back. So we can create a circle shape, and we can create a fixture from that, and I believe we then add that fixture to a body, right? Okay, so this is what I want to do. We actually just need to instantiate fixtures in our system. Yep. In our physics component. Right, starting position, right, we have body, great. Public list of fixture. Initial Let's just call this fixtures. And we might have to synchronize this to make sure that it stays updated. And we'll get to that. Yeah, we'll make that work. But sorry, so before we add our body, right, we want to create some fixtures now. What kind of shapes do we have? I was wondering if there's a line shape. There is a, let's just see, a circle shape. Let's get shapes in there. Oops. Let's take a look at the reference to Farseer. This is collision shape. So it's a circle shape, edge shape. I'm looking for an edge shape. Because we just want to make a box that, we bounce off the screen, right? Edge shape. We need 4 edge shapes, by the way. Edge shape, ES1 equals new edge shape. Okay, so we need some start and end points vector for what we want. So this is going to be 0, 0, 2, and we'll do we'll just do it in clockwise order, right? A new vector, and this should go out to so 0, 0. We're 800 floats, and of course this is the first edge. ES2, new edge shape. The italic namespaces look weird. Yep. Are you using some add-in which is formatting? Yes. Well, no, this is just Visual Studio 2015. You mean this right here? Visual Studio 2015 does this. Essentially, if I control period this, it's going to remove everything, all the namespaces not being used. Icosol, no, it's not. We are developing an open source real-time game engine. All right, so new edge shape, actually I'm just gonna, I don't want to type a whole bunch of stuff. 2, 3, and 4. Okay, so we need this data goes into here. And this is gonna go from upper right to lower left, right. So X will stay at 800. Now this is going to go to 600. And now take this and move it into here. And this is going to go, we're on the far left now, which should go to 0. And the Y is still 600. And now we got to go from bottom left up, back up. And this will take us right back to 0, 0. All right, so there's our 4 edges. We need to create a fixture for this now. How do we create a fixture? Oh, crap. We got to create it off the body. Or we can create a fixture from a factory, and it's not tied to a body. Let's create all 3. Oh, this will actually give us a new body. I don't like that. Oh, I don't want to create a fixture off of a body. I want to just create a fixture and then attach it to a body. Which means I would have to... Okay. No, this is okay. Add component is in italics. It is in italics, yes. That is Visual Assist doing that. But I'm going to sit back and let you then try again later when you're done. I need to add in Artemis Fire via NuGet. It should, Rob, that should get NuGet. It should download those automatically when you build. Is it not doing that? Could not be found when I try to build the other projects too. I'm a little out. Is Asgard server building? That might be the problem. Try and just build the Asgard server and see if that works. Okay, so I can't create fixtures ahead of time. We can, however, create our edges. So this is how we have to make this work. Because fixtures really have no data. Well, a fixture has a size, right? But essentially a fixture is the consolidation of a bunch of shapes. Yeah, and then maybe some offsets. So let's do this. let's create a fixture proxy. So public class fixture proxy, which has a list of hopefully this has a base class. Let's peek that definition. Is of a shape. Okay, good. Oops, nope. Keep go. That's what I want to do. List of shapes, right? Shapes. Get and set. And then float size. And make these public. Didn't seem to download, but interesting, Rob. Interesting. Yeah, that's not good because NuGet should auto download, but sometimes it is. All right, so then we're gonna have a list because you have multiple fixtures per body, right? So we'll have a list of fixture proxies, and I think we can get this to work. So let's go back to our move server. So we have a list of edges, right? So now let's create a fixture proxy. Fixture proxy, FP is a new fixture proxy. And go here. I just want to set up a public fixture proxy. I just want to make sure shapes is initialized. Make sure it gets set up properly. And then we need fp.add es1, 2, 3, and 4. And then fp.size. I don't know what I want. I don't know what I need to make this for. I gotta look at the physics system. We'll refactor that in a second. And then we want to physcomp.fixtures.add our fixture, right? One more thing I gotta fix. Public physics component. Fixtures is a default list. Okay, let's head back into the server, into our physics system, where we're attaching and creating the bodies, right? So this is where we get all our data up. And then we'll say if pcomp.fixtures. Well, we don't have to do that. Let's just loop through them for each var fixture in pcomp.fixtures. Var fixture is equal to body.create fixture. That's where you can only have one shape per fixture. Is that right? That can't be right. That can't be right at all. Or am I not understanding fixtures properly? Let's actually go take a look at source code. Weird categories, okay. Fixture proxy, right, that's fine. So here's a fixture. So when we create, that's internal, body shape. It's a polygon, I don't care. Otherwise, we set body, we set shape, we clone the shape actually, and then we register the fixture. Oh, that's right, and shapes can have, if we need density and all that fun stuff. Okay, I guess that means we just have to do a little refactoring here. Well, let's see. Fix.shapes is 0. I just want to see something real quick. Oh, that's user data. That's perfect. Okay, I don't care about user data. That just means in a we just need a list of shapes. Simplify our life tremendously. Right, we don't need this fixture proxy class. That can go away. Now we go back to move server here, and instead this is why am I calling equals? But okay. Dot shapes dot add. We just got to add all the shapes that we want to register, and they will get bound behind independent fixtures. And we probably will need to set some type of proxy up, by the way, because when we start doing collisions happen at the fixture level, and sometimes you need to know which exact fixture it hit for various reasons. But we'll cross that bridge when we need to cross that bridge, right? So we'll go through shapes. Okay, so now we can create a fixture for the shape. And for now we have no user data. And that's kind of all we have to do. The body we actually don't need to store it, but in case in the future if we want to do anything with it, right? Because we can start setting collides with data. There's a whole bunch of data that is going to be important for us. So we have to figure out how we want to start doing this, because it'll start getting more complex for initial setup. And maybe we can do like a callback too, by the way, once the body is actually created. Or maybe we'll just start creating the body ahead of time and not wait for this stupid on add. We might refactor that way too. But for now, here we go. Move server, right? So we've added collisions. Or we've added this. We need to add a circle shape for our ball, our little ball boy on login, right? So we're creating that. All right, so that's good. Let's see. Var shape is new circle shape. Radius is 20, and density, we'll just give it some density. Okay, that's probably super dense. Actually, that's probably not that dense at all. And then we just want to phi data.shapes, right, .add this shape. The question is, will that give us basic collisions ahead of time? Well, I don't care about being notified. Let's see, and also on our server simulation on the move server and our render system, I'm gonna render out our fixtures. Can I render out our, because we have the components, we have the fixture data. Yeah, let's do that. And then for each var shape in comp1.shapes. Sorry, if shape is a edge shape, var edges shape as edge shape. Watch this, we can tell. What's up, Kirkout? What's up, buddy? Long time, buddy. It's been a long time. Plans to make an editor for the game ending. I don't know, Summit. I don't know. I do not know. I don't have an answer to that right this second. Okay, so we're gonna grab our edge. Now from an edge, hopefully we can get star. What do we probably have vertices? I don't care about radius there. So we have our verts, and I'm assuming it's only going to use two verts, vert 0 and vert 1. But we might. Oh, there's a shape type. We don't have to do an is cast. That's fine. You think an edge shape would make it easy to get Well, there's also compute, which will give us a ref transform. I don't care about that right now. All right, so it's either vert 0 and 1 or vert 0 and like 3 that we need to use. Because this is an edge, it doesn't have 4 verts. We only care about 2 points, but it might copy them over. Yeah, Cornflower likes to use random emails for creating accounts, apparently. Oh, we just want to draw these though. Back buffer dot fill. I want to fill a rectangle because I want to give it a little bit of thickness. Well, we could draw a line with the thickness. Let's just do that. Draw a line. New pen from brushes. That's not how you spell brushes, guys. Dot black. Not beige, black. Thank you. Draw a line. I want to give this a size. Maybe you can get that from the pen. There, width, right? So we give it a width of like 3 pixels. Let's see what that does. Okay. So from point, edge, verts. So then we got to say new point, of course, from edge verts 0.x and edge verts 0.y. And the new points, edge verts. Let's just try 1.x and verts. Edge verts 1.y. And this needs to get floored out, and that'll be good enough for our little test scenario. Obviously, you don't necessarily want to do this. You probably should floor it first and then cast. But for our test purposes, I think we'll be okay. All right, I want to put a breakpoint in there. I just want to see what happens when we get a client connected up. Apparently, we have no data. We actually do have shape, but the shape is... Oh. Sorry. That is... Let's put a breakpoint there. I might not be adding it. I might be messing up. And let's go back to move server here real quick. That's login is fine. That's getting the shape. No, we do add the components. I'm trying to see why our physics entity... I might need to store this. This might be getting garbage collected. Where did you come from? Here you are. There is that's possible. I don't think that's really happening, but just in case. And then we'll also to be on the safe side, 2D physics system. That's when remove happens. Let's put an on add here and see what we get, because this should happen immediately, right? Oh, we don't have our world yet. That's what's going on. We haven't created the world yet, because I guess I'm being a dummy. I'm doing things out of order. Because this happens in start. Actually, I should have a world. What's going on there? All right, let's debug. Let's see what I broke. Better be cornflower blue. Oh, no. Physics system worlds are saying we do have a world. Let's see if we're able to get the world. Okay, we get the world. We create a new entity. All right, we have a world ID of 0. Create all of our shapes. I didn't set the world ID, but that's... I mean, I need to fix that, but 0 and 0, that should add up. So when we get into our physics system, why do we have no worlds? That's really bad. That is tremendously bad. Because we're looking it up and we're creating the world. And in the physics system, we're not able to find the world. So I'm just trying to figure out what I broke. That, where are we adding the physics system? Let's take a look at that. Not there, sorry. Okay, we'll reload config. All right, we gotta do a little debugging. Create our physics system. Let's make sure we're able to add this internally. And value. Oops. Oh wait, hold on. Oh, we gotta add it, that's right. I want to mark this, I'm gonna mark it. So that way we know this object instance has an ID. And then we also take the system when we set that in the entity system. And let's double check that. If we look at systems, uh-oh. This got a new instance. This is not the same instance as, see how system has a mark on it? We need a debug in here. It looks like it's creating a new, I don't know why it's doing that, because I'm setting a system in there. So that's our problem. We have two, we're getting two physical system instances. So let's mark this again. If I can find the mark. Let's throw it into our watch, actually. All right, so we have an object ID, right? Let's debug through here and see what happens. Oops, go away. I don't want the diagnostic window open. Do we have this? We don't. So, oh, we're gonna make this generic. So the generic type is a type of list. Oh yeah, okay, that's fine. So we have a type of our physics system. That's cool. Look at that. We're doing an activator instance, but that's fine. We're just creating a list, but this is, we're just adding this, right? So boom. So if we look at system of our physics type, and if we look at the value, okay, that's fine. Maybe I just wasn't looking deep enough. So update. Let's make sure this doesn't mess anything up. Create a new system layer. That's fine. And we're going to break out, set the bits. Okay, so if we look at the systems again, if we look at the value, okay, no, that's correct. Okay, now let's step through here. Oh, don't need a breakpoint there. All right, now we're gonna go look up the physics system. We get back the instance we're looking for. That's great. Get a world ID. I created the world, right? So if we look in here, we look at our entity world, our worlds. We have a world. That's great. We're actually even able to look up the world. Okay, all this is fine. Why is the move server starting twice? We're creating, let's see, get the physics world. We created a second world, by the way. That's not good. I mean, sorted systems, Bifrost server. I just want to see what happened here. For some reason, we're starting our, we have a physics system. Oh, we have the move server in here. That's fine. The player system in our physics system. But why did the move server get called? We called start twice, and I think that's a bug on my end. Oh, well, of course it's a bug on my end, but I think I know what it's coming from. However, that should not affect too much here. It just means we're going to have two worlds created, and one of them is going to kind of get ignored. Or they kind of should get ignored. So now, here we are. Okay, let's see. This is the correct instance. When we look at this and we look at our worlds, okay, we have a world. but when we get the world, it's no. Oh, because are we overwriting our world? Oh, we overwrote our world. All right, so a couple bugs we can go fix now. I know what's going on. Create a world. Why? Oh, because on start we screw stuff up. We overriding that. However, I also want to take a look and see why move server start is getting called more than once. Let me see where this is coming from. So I don't need you anymore. We know you're fine. Okay, call stack. We call start, and we should not be calling start. Hopefully that doesn't mess anything up. So start will still get called now, and it's being run from our run method. Okay, good. Get rid of these breakpoints. And now when we come in here, we should be able to get the world. Good. We'll get our body. Excellent. We have a bunch of shapes. We're going to start creating a bunch of fixtures. Okay, this stuff is fine. Now it all comes back to rendering, right? And we should actually check to see if it's a player in this. We'll make that update. And we should not be rendering this body position as well. So we're going to make a little update in our code here. But we do have our shapes. They are edge shapes. More importantly is what I want to look at is our edge.verts. Okay, so we need vert 0 and vert 2. And after I get this working, guys, we're going to do ourselves a little Steam game giveaway break. Because we've been at this for a few hours. I think we can do a little Steam game giveaway. Yeah. All right, so we want to make a quick fix here. We just want to say var player comp. Let's see if this has a player component in the entity. Get components player. What do we call it, by the way? Do we actually have a player data? Is that? Yeah. And actually a player component is what we're looking for. Well, that worked. Hold on. In the move server, I just want to double check. On login, we create player data. So get component of player data. If this is not null, then we know this entity is a player entity, and we can do this. Otherwise, it's just a physics entity. Because we're dual purpose in this now, right? All right, let's see what happens here. Okay, so 0 to 800. All right, let's just run this. Let's see. Whoa, that is not correct. I have a bad line somewhere. Right? I just have a bad line somewhere. So we have this line is good. That line is good. All right, so let's debug through these and see where I'm screwing up. Actually, let's do it from back here. Okay, so that's fine. We can look up our edge. So we are trying to draw from 0, 0 to 800, 0, right? So that's our top line. That line should be fine. Next line, we're trying to draw from, here's, this is now from the bottom here. So we're going from 0, 0 to the bottom here. That's bad. That's not the right line. So I'll go fix that. And actually, while we're doing this at the same time, let's look at moves. Where are you at? Yeah, let's go take a look at it in the server. And maybe I just typed these out wrong. Why is it going from 0, 0 to 800? I don't have that as a vert here, as an edge. 800, 600. Where vert 0, 0, 0. I don't have that in here. Right? Am I freaking out? Do I see 0, 0 to 800, 600? What the heck? 1, 2, 3, 4. What the? What? Because that was our first. That one was fine. The next vert we really should be getting out of here. The next edge. Oh, this has some interesting data. 0, 0. Why does this, this is as the shape, and that's us casting it to an edge. As a shape, it goes from 0, 0 to 8, 0. Maybe I don't want to, because there's our two verts. 800, 0 to 8. Oh, there. That's what I'm looking for. I'm looking for these two verts, which in this is vert 1 and vert 2. Okay. This is what we got to do then. So we want to use vert 1 and vert 2, but we don't want to cast this. We just want to keep it as its shape. Doesn't that give me verts? Oh, okay, maybe I do need to cast it as a shape and use vert 1, vert 2. Bring on the game gateway, everybody can enter to win. Yes! Yes, but not yet. Not yet. I will let you guys know when the raffle is open. Okay, now we're back to checking. Let's see, maybe I'll get this right now. 1 and 2, right? So 0, 0 to 800, and now 8 to 6. Okay, this is better. I bet you it's gonna look fine now. So if we expand this, we can't see it because we're clipping the drawing, but I believe we're drawing everything we need to. Question is, will we bounce off of it? Which means we should be applying forces, not just setting linear velocities, because that's going to hit and it's just going to hold it there. But let's see if collisions are happening. Debug, because that means it'll stop at the wall, right? I should up our speeds, because it's going to take like 30 seconds. I'll up our speeds on their next run, by the way. We'll get the speeds moving. Oh my god, this is like watching the tortoise try and win the race. Will the tortoise win? It's going. It's making it happen. And I should reverse the... Oh, no good. And if I increase our size... But that's... We should... Oh, sorry. This is what I'm going to do. I'm going to use 3, but then I'm going to offset some stuff here. Yeah, by 1 on all of this. I just want to see this real quick. That's still not drawing. I'm trying to find why this is off so much. Or am I going too far? Am I not? Let me see. Let's see. Our stupid little draw window. Open up. Our draw window is 800 by 600. Let's increase that size just a little bit to give us some room. And why are we not rendering properly here? We should be seeing those lines, those super sexy lines. Take a look at this again. My back buffer, DPI is good. We have no clip bounds, which is fine. No clip region, which is good too. And this is 800 by 600 is what our draw size is. And we are drawing to X of 800, right? So we're going from 0 to 800. We are going from 800, 0 to 600. And then we're going from 800, 600 all the way back over. This should be fine. I think I might increase. This is what I'm gonna do. Our back buffer. We might be hitting a little bit of. We might be hitting the edge of our and not. It might be in the clip region, or right outside the clip region. But no, that's so freaking weird. I'm gonna give this more size, because now I'm super curious on what the heck's going on. That's not what I want to do. Right, that should be way bigger than what we're trying to draw to. There we go. There we go. All right, so I don't know why this. Okay, so let's start clipping this back in. So let's see, 8. Right. I'll get it there. I guess I was just a hair too small. So that's big enough. Okay, that we need to increase because we have to deal with the title bar up there, right? There's a whole bunch of crap we have to compensate for in our little test model. All right, but now we can see there's our full box, and that's good enough. Question then, if in the move server, when we connect a player, and on login, we're gonna give them, sorry, that's actually in our render system, where we're doing our stupid move. I wanna move them reverse and see if they collide with that wall right up there. Or if they go past the wall, then we know we don't have a collider. We gotta get a client connected. And you can see it just went right past that wall. It flew right past that wall, huh? And we do have, just to double check, we are creating a shape, which will give us a fixture on our player, which gives us density, gives us the radius. We can make it smaller just out of, just to see. Uh-oh. I might have to turn, put these into like the same collision group or something like that. Let's find that out. I wonder if we have to do that at the fixture level. Sorry, I'm learning this physics component just like you guys might be at the same time. And that's what it's all about. All right, so we're creating our fixtures, right? Fixture collision group. So we can give this a collision group of 0. We're gonna give all of our collision groups the same collision group, and then fixture collides. We want to be able to, oh, there's categories. But let's see if group works. How's everyone doing this morning? How are you guys all doing this morning out there? Nope, still not colliding. So on collision, we need an on collision handler. On, oops. Is equal to, what the heck? Let's try that again. On collision. He doesn't know what an on collision handler is. On collision event handler, is that what it wants? Yes. Which is fixture A, B, and a contact. Okay. So we're just gonna do this. On collision handler plus equal to A, B, C. I just want to bake something in real quick. Just to see if we're actually getting some type of collision and maybe we're just ignoring the response. What doesn't it like here? Oh, we have to return true. All right, let's put a little debug in there. Move client debug. I wonder if it's because we're doing line and maybe we're not doing the right side of the line. Oh, look, there is a collision. Here's our fixtures. We have a body. I don't care about the body. This is our fixture, right? So here's our shape. This is an edge shape. Do you think they would have built-in colliders that we would not have to write our own on collision? That collision should just be happening on their own. Sorry, King Recycle. That doesn't sound fun at all, man. That sounds kind of grueling. So, all right. So if we just say everything collides all the time, let's see what happens. Nothing happens. Let's add a new client in here. Is this because I know I'm constantly giving it velocity, but even in a physics system, if you constantly give something velocity and it's colliding against it, won't punch through the collision. So I think we're gonna have to go look up farcier collisions. So on collision, we want the collision to happen, so return true. Sure, I want the collision to happen. Absolutely. You can also do broad face collision. Okay, that's cool. Maybe it's the wrong. Let me debug this again. Maybe I'm getting edge to edge collisions, not edge to circle collisions. I actually did not check the other fixture. Right, so we are colliding with a shape, circle shape. We are colliding with a circle shape, right? So that's our position. Oh, this is. Oh, I know the problem. Sorry. It's not that collisions aren't happening. The collisions are happening. It's just that we have a line, and I'm rendering I'm initially positioning a circle right on top of it. Since it's a line, we're actually able to pop in any which way, but then we won't be able to pop back. But that's what's going on, and then we're just popping past it. So I need to render our ball into the in the box, not on top of the line of the box. And that's easy to do. So when we log in, right, we give it an initial position of 0, 0. That's bad. Let's give it 400 by 300. Right in the center. And cross our fingers. Move client. Debug. Damn it, I forgot to increase our velocities as well. But we're gonna sit here. We're gonna wait it out. We're waiting it out, guys. It's getting crazy in here. Uh-oh. What the hell? What just collided? We're so far away. Unless I have a radius set really bad. Here's our edge shape. So we are colliding with 0. Okay, so it's our top vert. I wonder if it's because we have to give a position of... It's at 0, 0. I gotta take a look, by the way, because obviously a body can move and have its fixtures around there. I'm putting is Farseer centroid positioning is what I'm trying to get at. Is Farseer centroid positioning. We can render based off that and see where the rendering is coming out because of that. Maybe we'll. Because in our other body here, right, we have a position. Where's our position at? Get the body on the floor. We have no force on it, of course. We have a position of 104 of 4. And that means we're at a Y of 4, but we have a radius of... Oh, I can actually look at that here. From our shape, what's our radius? We have a radius of 5. Okay, so position 4 radius of 5. You think that'd only be 2.5 if it was centroid positioning, right? Because here's our... we can actually look at the contact. Why didn't I just go look at the contact? Where are we connecting at, right? Here's our contact edges. Oh, we actually have a manifold. So there is our points, our contact points. Maybe I'm overthinking this. Maybe I was just overthinking this. And yeah, I guess we were just hitting the top edge right here. All right, so I'm gonna update our velocities to 30. See if we can get this bad boy moving. Hey, what's up, Ragathan? How you doing, buddy? Ragathan, is our positioning centroid or not centroid? So if I create a shape or a fixture, okay, right there, right? So that's where we are colliding with, and that's fine. It seems like... Oh, you know what's going on? We're drawing at upper left. We're not drawing at centroid, but we have a small little ball here that's at centroid, right? So that's why we're colliding right here. It's just our rendering is off because we're not rendering at a centroid positioning, and we can go fix that. Essentially, we know we are 20, so we just need to take 10 off. And I know I'm hard coding it, but that's why this is a test app. And I want to go back to our mover system. And I'll put my shape back to the right size. Let's see if that's okay. Okay, shape will be centered. Okay, perfect. Let's see if that is stacking up to what I'm thinking. Something is off. Something is off. So we're creating a circle of 20, which is fine. When we render 20, but this is an upper left, and our render point. No, this should be good because Philly Clips is upper left, not center. Used to come with the debug drawing library, was back then, but maybe Ragathan. I'm not so interested in the drawing aspect, to tell you the truth, buddy. But I see what you're saying. So if this is our centroid positioning, and I want to draw that, I'm trying to take half, right, of our radius. Well, actually, we have a 20 radius, not diameter. Hold on. So if is this giving me? This is not radius. This is diameter. So if I move off, so we should have a 10 radius ball. Because we're going 10 and then, wait, hold on. So I'm going back 10 and then I'm drawing 20 out. We have 20 in diameter, right? I think so. Uh-oh. I think, oops, whoa, that's way too big. Sorry, let me kill that, guys. I need to turn that off. I always keep forgetting to turn that off. Stream! Boop! Perfect. That was perfect. Now, what we kind of want to do is, instead of, as a test here in our render system, instead of adding constant linear velocity, I just kind of want to shove it really hard, so hopefully it'll bounce off of some stuff, right? So how do we add, so do these pulses, force, okay, we can apply a force, right? So we want to apply, and we'll just do this, I just want to do this one time. Okay, so we'll say if body.linear velocity, yeah, this is what we'll do. If the linear velocity dot x is 0 and y is 0, we'll apply a force and get it moving again. New vector of, in this week, I'm gonna give it like a big force and see what happens. Is there an impulse? Are there impulses? I couldn't find, oh, there it is, linear impulse, never mind. Yes, I do want to apply an impulse, not a force, right? And you can apply an impulse at a specific point, otherwise it'll be centered as it should be if body dots. What have you been up to, Ragathan? What you been up to, buddy? Something not working here. So let's take a little step in. We apply, was this too much of a linear impulse, maybe? Was that too much? Okay, good. So it looks like we moved, but then we came to almost rest. The problem is we're not, I need to clamp that down. So if linear velocity of math.abs is less than or equal to 0.001 and math.abs what's that, Rob? Less than or equal to, what's up, D-Hack Gaming? How you been, man? How you been, D-Hack? It's back from the dead. It's not it's not back from the dead. We're not doing anything with X and A. We're not doing a dang thing with X and A. Trust me when I say that. You should use mono game over X and A if anything at all. So we have a linear velocity. Is that ever going to change? It seems like we're at rest at a very weird linear velocity. I mean, are we actually not moving at all? We're not moving. This is a weird, is this a bug in Farseer? This seems like a bug in Farseer. There's actually well, I guess it's not a bug in Farseer. That's our linear velocity. I should be checking is our positioning updating. 326, 527. Okay, so our positioning is updating, okay. Yeah, mono game over X and A, absolutely, right? Let's get rid of you. Is that still not? Are we still not? Oh, dang it. So that's what I want to do. Yeah, that will get me where I want to go. But I just hate the lack of sprite batch. There's no sprite batching system in Unity. There has to be some type of sprite batching system in Unity. I don't believe you. All right, so, and of course we're gonna stop right here, aren't we? I guess if we wait long enough, it'll come to rest. You know, if we give it more density, but nah, I want it to move. Or should I not be applying a linear impulse? Maybe I should just be applying a force. But then that's, as soon as I stop, it's not gonna apply the force anymore. Into the crowd. What's up today? Crowd. We are connected, but we're never. All right, what did I just break? Sorry, guys. Something weird just happened there. We didn't get a physics simulation. Did I not start a client? Did I start 2 servers? I might have started 2 servers. Okay, so we're gonna apply a force. Okay, now we're gonna keep applying forces. Let's see what happens. How does this look? So we're applying a force, but it's not enough of a force, obviously, and it's not keeping us rolling. Yeah, I don't know if I want to do an impulse, because it seems either friction is too high, but there's nothing it's frictioning against. Because our impulse is, we're losing energy really fast. And we start coming to a real slow velocity that never ends. All right, I'm going to get rid of any impulse. Apply. I'm going to go back to force. All right, Rob. Later, buddy. So I'm hoping they made their own. I hope they did. I hope so. Oh, what am I? Don't want to apply torque. I want to apply a force. I just want to get this sucker moving. Like one time. But for some reason I can't get it to move. I can't get it to actually start applying some forces. Let me take a look. There's linear force. There might be also, there's angular, which we're not doing anything. It's awake. There's no force being applied. Why is no force being applied? It has inertia. It has a lot of inertia. We might have to debug in and see, or look to see what I'm doing wrong. There's no dampening. It has some mass. I'm trying to figure out why we won't move. Joopy Joopy, 1, 2, 3. Hello. Hello. How you doing? Why? All right, Ragathan, you've used this library before. What's going on? I should have like some velocity going here. Stuff should be moving. Is it, am I messing up my position? See, 10, 10, 40. Oh, okay, hold on. This might be us not rendering properly here. Because we're at 306, we're at 393, 398, 405, 412, 417, 423. All right, we should be moving. This should be like moving around, but we're stuck right now because we have our back buffer that we're filling. Why are we not? Did I delete our draw? I messed something up. We are not... I guess we're just getting one draw in here. Draw image of our back buffer. Is that what I'm messing up here? Not bad. Draw image, not our back buffer, but our bitmap. Which take, oh, right at 0, 0. Hopefully this is gonna fix, I don't know why it was all messed up. I don't know where I broke this. I might have to go compare our previous check-in. Because we're not moving. We should be moving, though. This is what I'll do. All right, so let me undo what I just did here. Where am I? Where's my writer? Okay. All right, let's get rid of you. Because we definitely should be moving. If I take this... Yeah, okay, and say trace dot right line string dot format 0, 1, and then we dump out our components here. Oh, I just figured out my bug. Never mind, I'm gonna get rid of this. Helps to actually validate our inputs, right? Gonna have to validate our inputs. All right, so if I did things correctly here, this stupid ball should start flying around. Of course, it is moving absolutely 0 still. I'm a sad panda right now. I'm a sad panda. All right, I guess we are gonna spit this out. Let's see what the heck's going on. Some time no one is going to deal with you if you have an experience cannot make a game. What's that, Preston? All right, let's see. So you can see we are... Oh, we're not moving. Well, we're moving, but you see, we're moving extremely slowly. We're moving so slow, it's like glacially slow. Why are we moving so slow? Obviously, our force is gone, and we have this horrible linear velocity. I'm gonna say, all right, if this is less than 1, this is not what I want to be doing. I don't know why I can't think of why this is broken, why it's not dinging on me. So this is moving a little faster now. Am I just not giving it enough of a force? Is that our problem? Is this just too small a force for like the density that I have? All right, let's start amping it up. Let's just amp it up. Let's just amp the sucker up. So we're starting to move faster. Holy cow! How much do I have to give this? How big does this have to be? Right, it's all about the magic values, guys. Remember, this is just a test. This is not real code. Just a test, not real code. So we can't keep applying our force, of course, right? And we want to give some restituity so that we get some bounce. Less than... Let's just go this, because I want to just have this happen one time. And I'm going to give it a huge, huge force. You just discovered entity components. Nice! Alright, this happens if we just apply this force once. How fast does it die off? And if it dies off real fast, then we got to take a look. Maybe we have too much mass. Alright, so that's the force being applied just one time, right? Which means eventually we're going to slow down. And we're not bouncing right now because there's no restitution. Or we're actually not... I wonder if we can get a... And we should put... I'm going to put... We don't need this away. I just want to trace... Right. Line... Force. Whenever we apply that force, just so I know if it's happening more than once. Which is fine. Shape is there. Red. There's density. Let's see, density. Let's give it a real small density. I don't know if there's like a restitution property that actually might be on the shape, because where, well, shape dot, is there friction? Is that at the body level? Oops. Let's see, restitution. All right, let's give this a high restitution for testing purposes, and we'll pass that in. We'll have to have a shape proxy. Whoa, man, people just calling right now, and I should turn that off. All right, going away. There's our bounce, right? So that's what we're looking for. We just want to start getting this sucker bouncing so that we can see what happens in our client simulation on how it's interacting. Now the question is, can we... we're probably going to start hitting a clamp here on how much force we can give it. But I don't know why we should be able to get this thing moving, you know, as fast as we want. I don't know why it's not. Go away. Because that's extremely slow. Right? That's extremely, extremely slow to be bouncing around on. And then eventually, if we slow down enough, it should reapply it. Boop. We need to update this to be the same sizes. I am not using XNA, no, guys. So we're not developing a rendering system. Just so you guys know, we are developing a open source real-time game server. It's not tied to any framework. So no, we're not using XNA. The physics library that we use uses the XNA namespace just to define some types like vectors, but it's not actually using XNA. It's just it could be compatible with an XNA if it wanted to be. I want to move this faster, but I don't know how I can get this moving faster because this is, you know what, let's just do this. Float.max value. And then this is going to be float.max value divided by 2. Out of curiosity, let's see. This is as fast as essentially as we should be able to apply a force, right? And force.max value is not, it does not like force.max value. Wow, we have a linear velocity of nothing. So I want to apply a force. Body force. I guess this is too big of a force. I have little density, a lot of restitution. Friction shouldn't matter here because we're actually not colliding with anything. Oh, is this oh no, I set gravity off. There is no gravity. I'm sorry, I'm just trying to figure out why we move so slow. The force is strong here. Wow, it's not Sunday yet. It's not pun day yet. That's funny. Yeah, I don't know why those forces are so large. I don't know why I think those forces are so large. Let's give it a really large float number. And this one we're going to give half that. Please right-click on your solution and set Start Up Projects. Why? I am setting a startup project. I'm debugging multiple projects, my friend. And the projects that I debug at multiple times are different, so it's hard for me to just set startup projects because they change. You can't see an access is going to cause as soon as it computes the... Oh, I guess you're right. You're right, Ragathan. That's right. That's right. But why can't... I don't know why... Ragathan, maybe you can help me out here. Why am I not able to get my forces moving any faster than this? This seems to be the max force that I can apply. And this is extremely slow. Why is that? Why is this? Why is this? Is this because I'm using too big of a world space? Should I not be using world space? Is a whole number a meter or a kilometer? Yeah, we can use a multiplier. Here's the question. In the physics system, is 1.0. Is that a kilometer? Or is 1.0 a meter? A delta time along with your force applications. Yeah, but I essentially, I don't want to continually apply a force. I want to essentially just knock it. Think of it like a billiards, right? So think of it like billiards. I want to apply just a single impulse once and let it bounce around until it stops. So if one is 1 meter, we are simulating 800 meters by 600 meters. That's not that big, right? That's not that big. And that means every move step here is 1 meter, and it's moving pretty slow. I mean, this is moving slower than gravity. Ragathan, when I used an impulse, nothing moved. I mean, here, well, I can use an impulse again. Here, well, we could set an impulse, right? Linear impulse. Simple as that. We have to use such a large number to get any type of movement out. I'm not sure why. As you can see, it's still moving at the same speed, right? But it's moving extremely slow. There's no dampening applied, though. So if we check here, right, we'll look at our body. Let's see if there's any dampening at all. Linear dampening is nothing. We have a velocity, which is 13 right now. That's pretty decent, actually. So we're moving 13. That's pretty fast. Actually, 13 is pretty fast. Maybe we're just rendering poorly. Here, let's spit this out again. Trace right line. Right line, string dot format 0 1 comp body position, oops, X comp body position Y. It's no friction, no kill, right? I'm not sliding across the plane. I'm sliding in space, so no friction is being applied. If friction is being applied, something's wrong because air shouldn't have friction. I know you can model that, but by default, there's no friction. It is dynamic. Don't worry about interpolation because that's fine. This is server time, but here's our numbers moving. I guess our numbers are moving pretty good. You know, what is 10 meters per second? Let's see, hold on. I think we're probably moving pretty fast, and my view size is bad. I think I'm gonna go with that. Let me see something here. Because we're moving at about 10 meters per second, right? That's about 22 miles an hour. So this is moving at about 22 miles an hour. But I did have to apply a huge impulse to make that happen. Use string Oh, I know, Rag. I am using Visual Studio 2015. I probably should be using the new stuff, right? The new goodness. You're right, I should be. I should get up to speed. It's still a slow max speed though, Preston. I agree, right? But is that because my in my world, even applying such a large impulse should not. That's still pretty slow. For the amount of linear impulse I'm giving it, right? What's our linear velocity? Let's actually take a look. All right, our velocity is actually 21, right? 21, which is about 46 miles an hour. That's still pretty slow given, but this was just one impulse. Maybe it was fast at first and now we've been slowing down, right? And we've been bouncing off a wall. Let's see if we can do a little Google fool on Farseer. Farseer, linear velocity. That's a Box 2D tutorial, which I don't care. Inertia or velocity cap. Simplify code quite a bit. I've got a body with a mass. I apply linear impulse, and I scoot the object to the right using a vector and constants. Probably it does move to the right, but it seems to be capped. Goes up as I increase the value, but the actual change does not. As soon as I call world step, drops back to some tiny value. What important is the weight ratio between objects? The bigger the mass, the higher the force needed. Maybe it's because maybe I'm setting a high mass. Let's go take a look at Gotcha's speed limit. Oh, there's a maximum movement limit of 2 units per time step. Set in settings. But beware that the value in this value tunes. And we are doing a time, we're doing, we might need to increase our time step. We're doing 30 steps a second, which means our max movement is 60 meters a second, right? No, hold on. So we do 30 times, yeah. Our maximum movement that is allowed would be 60 meters or units a second, yeah. Bounce will reduce speed, yeah, of course, a little bit. I have a high restitution, but it'll still reduce. But you really don't want to change this. You should scale your world, right? So that 2 is big enough. But what's these gotchas? Hold on. So typical frame rate, a body covering 2 units per time step is moving 120 meters or, well, hold on. So typical frame rate is 60 hertz. We're not running at 60 hertz, we're running at 30 hertz. So we should still be able to get like 215 or 135 miles per hour. Let's see, why do bodies lose speed after bouncing? Even restitution is up to 1. Yep. Okay. So, all right, so that's that. That's good to know. Let's see what this guy's doing. I added a view and extend. Let's see. What's this guy doing, right? So he has linear velocity. I don't like linear velocity. I don't like doing linear velocity because then you can't do bounces unless you adjust linear velocity in the collision. What's up, Poopdrax? He has no angular, he has a linear, and that's it, I guess, huh? What's he doing in projectile active position? Is friction? Is there a chain? We'll track down. I tried creating new instances of projectile. So this is not what we care about. This is someone having a problem with linear velocity, right? Oh, there's a settings to limit frame rate number. If you want to use different timings. So physics has its own update simulation. Maybe we don't have to do our code in there. We should look at their code because we're writing our own version of that, right? Doesn't work for me because everything is now super slow and Projectile seems to have no power. Maybe try out limit frame number, which helps testing a lot. Set it to 5 and 1 for extreme scenarios. Maybe we need to mess with the frame number stuff. Gotta make sure physics units are an okay size. Yeah, but what the default unit level, right, of 1 unit, 1 meter by default should be fine for almost all cases. And this means we should not have to apply some crazy linear force like this to get this sucker moving, right? Now, there is a possibility that I'm too dense. But that's not true because I sent a really small density, right? But this is not, oh, wait, this isn't mass, is it? This is density, that's not mass. Let me see if it's calculating our mass. A large one, a large Dutch company. Game time, Tech Andy? Game time. Okay, sorry, 1 second. Do we have mass? So we have a mass, and our mass is 0.3. And typically the mass is the sum of all of your shapes or your fixtures. Let me take a look here. If I can find, where's my fixtures? Fixture list. So there's a fixture. Fixture sometimes has mass or body. So how's it calculating my mass? Because I gave it a density. I gave it a density. Where is it getting mass from? Right, because there's my mass. But I don't know where it's calculating that from. Is it calculating based off density and area of my fixtures? That's possible, actually. That might be going on. All right, let's see what happens at... I don't think I'm going to render anything because I was paused too long. So I'm going to close this down. Let's see if that helps. It calculates mass in the constructor, but mass should be calculated based off a density. Typically now, mass is calculated based off the density and all of your fixtures. So, question then. I mean, we could see, right? So when I create a, I don't create the objects here. Oh, shapes have, oh, right, I'm sorry, no. Your mass is the sum of all your shape densities. Right? It should be calculating your mass based off all the shapes and their densities. Let's see here. That looks like we're moving a little faster now. And to double check, where's my render system? Right here, right? So if we look at our body and we go find our mass is much smaller now, and our linear velocity is now 25. Okay. So we just have to have a really small density. I think density probably defaults to 1. Shape density times area. Yeah, there we go. And then it's the sum of all the shapes on the body, right? And oh, you know what? You know what's actually what's causing our density, our mass to be so large? We actually have a really large circle. Our circle is 20 meters by 20 meters. We're completing a full update of the frame. Well, not necessarily, but we did a fixed time step, right? We have a 20 meter by 20 meter ball that we're trying to move around. So giving it a density of like 1 or 0.1 means it's going to be a huge mass. So we just have to compensate in our test app by giving it a really small density. So even though it's really large, it's very light. And then I think we can get the sucker moving. Or crash, who knows? Give me a second. Why are we force? And I should put a... We're not moving at all right now. Why aren't we moving at all? I might be too light. Let's see, what's our mass? Oh yeah, our mass is way too light. Let's put a space there. Way too light. Hey Red Lab, how you doing, buddy? It's starting to come together, man. Starting to play with some physics here, and then we'll see how network physics look when I can get a proper simulation going. So yeah, sorry. Let's play with it. What? All right, this is what we actually should be doing, guys. Let's stop messing around. See how we're creating this circle of 10, radius of 10, right? It really should have like a radius of 1. And we should, we just need to do some clamps. Oh, that's where I give it its, I'm overriding the density there, but I shouldn't do that. And then we'll give it a density of 0.001, right? So we're gonna do a little bit of work here. We're gonna convert some data. So our starting position now should not be half our screen. Let's do, we're gonna do 10, a reduction of 10. And at the render scale, we'll just multiply by 10 to get us rendering back to where we're looking for. And then that means down here, right, 80 meters, 60, 60. Yeah, this is our problem. This is our problem. We're trying to move around its object that's way too large for itself. Okay, that will fix there. In the render system, we just need to multiply this times 10. Multiply this times 10. And that'll get us back to where we need to, and the same thing for here. And we'll have a proper system for this, outside of just simple testing. I think that, and now obviously this is gonna look a little weird. And the client-side rendering is gonna be broken, so I'm not even gonna show that, because we have to do the same clamp on the client side, because it's using the raw numbers. But I just wanna see what's happening on the server. There we go. Oh my god, look at the speed on that, right? Okay, perfect. Supersonic skyscrapers are a bad idea. They are a bad idea, right? Ragathan, they are a bad idea. But this is what I was looking for, right? This is what we wanted. And we're gonna have to really soon move away from using WinForm's rendering, because it's not able to render smoothly enough for us. Rag, why'd you get timed out? Was that you, Cornflower? Oh, that's just mean, dude. Cornflower, it's mean. But you see right here how we're only rendering in this little space right here? Boop! Boop, because we have to reapply our numbers. You just tabbed into here and that would happen? That's so mean, Corn. That is so mean. Oh my god, we're moving so fast. We should, this is good. This is fine. Break, debug, terminate. Let's go to our client and fix the client now. I'm happy with the speed that's going on there. Yeah. 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 In our main form, we're going to get data. When we need to render it, it just needs to be multiplied by 10, right? This still looks like a slow max speed. Well, remember, we're still rendering a... I think the max speed is not that slow, Ragathan. For one, we're bouncing off and we're losing some... We start losing speed pretty quickly. But also, this is still a 1 meter by 1 meter object. And remember, there is a max. There is a max change of, for us right now, 60 a second. So I think 60 meters a second is the maximum speed that we can simulate in the current system, which is pretty fast. And our world here is 80 meters by 60 meters, and that's still pretty big. I did not want to fire up the chat client. I want to move our chat server. There we go. All right, guys. Now it's do or die time. It's do or die time. So this is... Oh, blue has to get extrapolated as well. So red, by the way, red is our simulated space, and it looks actually pretty good. Blue, for some reason, I'm not extrapolating because I guess I messed up. Oh, yeah. We do that down here on a snapshot. I'm like, why is that not working? And more importantly, I want to update our sizes here. All right, here we go. Now we should be able to see the difference between interpolation and raw data. Oh man, are you serious? And then if this works, we're gonna take ourselves a little giveaway break. It's gonna be giveaway break time. Client debug starts. And there we go. Okay, guys, so this is, I don't know what, let me see how it might look on stream. I want to pull up my stream at the same time that this happens. So on the left-hand side, we have server. This is as smooth as it's going to get on the server, right? Obviously, we're not rendering efficiently, so that there's some tearing going on, but we're going to ignore that, right? But more importantly, on the right-hand side, we're not simulating physics. There's no physics engine running on the right-hand side. We're just sending snapshots from the server to the client, and then we're interpolating that. The blue ball, the blue ball is our live data. It's basically moving as a snapshot comes in. The blue position is the real-time network position as we get it. The red is our simulated interpolated position. As you can see, the blue is very jumpy, very, very erratic. It's because we're dropping frames. We have jitter going on at the network layer. We have 1 to 150, 1 to 200 milliseconds of lag. So there's a lot of things going on. That's why we never want to render blue, because it looks horrible. We render red, right? But that means we have to render in the past a little bit. Bad choice of color. It might be. It might be a bad choice of color. Set a transformation so you don't on the graphics object. Oh, I see what you mean, Rag. I'm not so, remember, the graphics here is just for testing. We're not actually developing anything with graphics. But sometimes we need to show stuff to make sure things are working, so we have some simple graphics. But there we go. And as you can see, because we have to simulate, right now we're simulating 300 milliseconds in the past. We're going to get that down to 100 milliseconds, by the way, today. But you see that we're plus lag. We're probably almost half a second behind the server. Do I simulate? Yes, yeah. So right now we're simulating some jitter. We're simulating packet loss, all that fun stuff. We're not making a game, MLG. We are writing a real-time network game engine. This is so exciting. This is so exciting watching these move across the screen. All right, well, we're going to close this down. But we're definitely not done. However, I'm going to say it, guys. It is Steam game break time. So give me a second. I'm going to get this set up for you guys. Let me get this set up. It's going to be delicious. If I can find it. And then I'll tell you what we're doing, what this is all about. All right, guys, if you're new to the stream or if you're old to the stream and you're out there, if you're lurking, I love it that you're out there lurking. Keep on lurking, but please, for one moment, come on back, come to the stream, go to go to a chat, any of my chats, live coding, Twitch, wherever it's at, and type something in chat. It doesn't matter what it is. You can put one letter, and then you can go right back to lurking. That's cool. But even though you're lurking, doesn't mean you should not have a chance to win some Steam games, because we're gonna do some raffles. And if you want to have a chance to win something, you got to talk. You got to say. No, so we will do extrapolation rag on the player. We're doing simulate interpolation for all other network objects, and the game just basically plays in the past, and it's up to the server to synchronize that knowledge. The problem with extrapolation, and yeah, there's like two schools of thought, right? You can do simulation in the past, or you can try and extrapolate into real time. That extrapolation completely breaks down when you have a high twitch movement. So in an FPS and people are moving back and forth really fast, erratically, extrapolation falls down. It doesn't work. You can't predict the future of something like that. Yeah, D-Lurk, everybody. D-Lurk for a second. Oh, we have a couple more games as well. Let me pull up my notepad. We have some Humble Bumble games that we give out if you want to choose from. So if you, and I'll give you some more info. Hold on, guys. If you want to pick a game from that list, you can, or you can click this link that I'm putting in chat right now and go through my Steam library of gifts. We have a few pages, and I need to start adding some more games to that so we can fill it back up. Starting to get a little sparse, but that's okay for now. But there we are, guys. We're in break mode. Break time! A lot of lurkers, Ekloff, and give people time. You know, they'll come around. They'll come around. This will fill up a little bit more. I get a lot of lurkers in here, Elk. People like to come in, start up the stream for whatever reason, and then go do their own stuff, get to work, and listen to me in the background. I'm like white noise for developers. I'm developer noise. But that's okay, because it's break mode no matter what for me. And I love me some breaks. Who doesn't like a good break? Let's see. Interesting. Interesting. Is everyone having a good Saturday so far? Everyone having an amazing Saturday? I'm having an amazing Saturday. I don't know about you guys. Hope you guys are. Where is my... There he is. Okay. Hey, what's up, Googles? How you doing, buddy? What's up, Googles? We'll give this a few more minutes, guys. Exactly, I switch your stream every time you're compiling. Oh my god, Amit, do you compile a lot? Are you switching all the time? Oh no. Oh no, you're having a frustrating Saturday? No, Elk, don't have a frustrating Saturday, man. So you're trying to get into Unity and C#, and that's cool. That's awesome. Don't let it frustrate you though. Just take a breath. Take a breath. Take your time. You're not gonna make a game today no matter what you think you're gonna be able to do. So if it's going slow for whatever reason, it's like, there'll be tomorrow, there'll be next weekend. It'll be okay. El Clasico, nice. I know, Google. I've been here for hours, by the way. It's not even early anymore. The sun's not even in my eyes. I can't wait to get my green screen back up. I miss having my green screen, guys. Switch every 2 minutes? Nice. Nice work. Alright, so what do we have left to do today? We got our physics system plugged in. We got to go clean it up, though, because there's some things we need to do about it. There's probably some other... I want to get tick rates decoupled. Right now, we're kind of hard coding some tick rate stuff. So I think that's what we'll do. We'll clean up the physics that we have, and we'll go fix up tick rates so we can define tick rates via config file and not lock ourselves on tick rates. We'll do that after some raffles. What's the raffle for Google's? Because it's break time, so we're going to raffle off some Steam games. If you want to see what's available, click that link or pick a game up here if you win. Is your name there, Demlar? I don't know, Demlar. It looks like it's there now. Welcome to the stream, man. How you doing? How you doing? It looks good to me. And if anyone's just joining the stream, remember Steam game raffle break time. Type something in chat if you want a chance to win a Steam game. You're coming from Game Maker, which you're quite good at, but in Unity I can't even do the most simplest things. Really annoying. You'll get it, Elf. You'll get it. New platforms, new systems. They can be difficult to figure out at first. Don't worry though. You'll figure it out. So you come from Game Maker, but you want to get into Unity. Okay. Okay, I can get behind that. Hey, Jobo. Hello, Jobo. How's Jobo doing? All right, guys. We're gonna, if we can get one more in here, we're gonna start this up right now, or we'll start it up no matter what in a couple minutes. But if you're just joining the stream, or if you're out there and you're lurking, come on, we need one more person. Say something in chat. Say something in chat. Get into the raffle. Don't miss out. Don't miss out. Oh, and there he is. MPEC. MPEC. What are you gonna ask? Ask who, Jobo? Jobo. All right, guys, here we go. Oh, MLG is also trying to get into Unity. Look at that. Look at that. Okay, guys, it's raffle time. If you don't, we'll pull two names. We're going to pull two names. We'll give out some games, and then we're going to get back to work. So if you hear my name, get back on chat, look around, say something. Dave, 3 of 5. It's on. Enderkin's on hold. We'll be back to it at the beginning of the year. Hey, Siphon. Hey, Siphon. How you doing? All right, guys. Here we go. First winner of the day is gonna be. Drum roll, please. Someone give me a drum roll. Out there, I can't hear it. Drum roll. Drum roll. All right, never mind. All right, first winner is gonna be Zolomon. Zolomon, are you out there? Please come back. Say something in chat in the next 90 seconds, and we will give you a game from my Steam library. But come back 90 seconds. Just say anything, and then we'll ask you what game you want. Otherwise, the reroll train starts, and you never know where it ends. Enderkin Station. Giveaway time, Stupid Geek. Boo, 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 boo. Where'd my music go? This is a really quiet opening to a song. There it goes. Stupid Geek, man, I'm excellent. How are you doing? 50 seconds gone, Solomon. Come back to me. Come back. Please come back. Uh-oh, we're running out of time on Zolomon. Chances everyone else is just going up. That's good to hear, Tupid. That's good to hear. Did somebody go crash Zolomon so he couldn't win? 5 seconds, guys, and then the reroll train is leaving. Choo-choo. The station. All right, guys, I'm sorry. We're past 90 seconds. It's reroll time. Good luck, everyone. Good luck, good luck, good luck. R Stamper 01. Are you out there? Are you out there? Please say something in chat. You now have 90 seconds. Come on. I know you're out there. Hey, what's up, Andy? Oh, Spectronaut. What's up, buddy? How you been? Too Big Geek, I know. You don't understand how many copies of Bad Rats I've actually given out in 2015. It's kind of ridiculous. We've given away so many copies of Bad Rats. I'm going to run a contest where first place prize is a copy of Bad Rats. R Stamper, man, congratulations. You get to pick a game from my Steam library. You can click that link right there and choose a game, or you can pick any game that you see up here on this list. Let me know really quick, though, and we'll get it going, man. Congrats. Congrats. And hold on, let's see if we can get the headgear on properly while we're doing this. Demlar, I don't know why. It seems like it's a buffer issue at the codec level. So, I mean, on Twitch, it's fine. I don't know why it's all messed up or a little messed up or buffery on live coding. I have plenty of upload speed, Demlar. And my stream is actually really low, Ben. It's only a 1.3 megabit stream. Lovers in a Dangerous Space-Time. I have not pressed in. R Stamper. I have no suggestions, but chat out there might have some suggestions for you. Chat might have some suggestions. Let's see what chat thinks. Bad Rats. There it is. There's the suggestion. What's it gonna be, buddy? All right, R Stamper. What are you thinking? What you thinking? I know it's a tough choice. Oh my god. He's taking it, guys. He just took the cheese bait. He took the cheese bait. Alright, if that's what you want, R Stamper, I do not stand in the way of mighty men. Give me a moment here. I'm going to send you a message. This is how this works. This is how this works. I need your email. I just sent you a Twitch message. If you can go check your Twitch messages, respond back to my message with your email address, and then I can have Steam email you your game. I need any email address, it doesn't matter. Just send me one. And then after I get that, guys, we'll send out another game, and boom, we're back to work. I have a new capture card coming in hopefully next week too. So I'm going to stop using my Extreme Cap 3 and move on to something much better. Hopefully that fixes some of my problems. You're in the raffle now, Juan. You are in the raffle now. If I link you a video of this game, will you check it out? It's a really fresh game I think you would like. Preston, I will definitely check it out. I don't know if I'll check it out right this second, but I absolutely will. If you need permission to post, let me know. You didn't miss it, Jacobs. We still got one more game to give away. No. That's a capture card. A capture card, Demlar, not a graphics card. Capture card, not a graphics card. Okay, permits. The Preston. Let me check my inbox here real quick. See if I got an email. Oh, I got your email, R Stamper. I got it. And I'm going to send this off to you, buddy. I want you to enjoy this game, R Stamper. I don't want you to play it all at one time. I want you to savor the experience that is Bad Rats, okay? Please, for me, savor it. Have fun with it, though. Not all at once. It's a little much. It's a little much to try and do all at one time. All right, guys, let's, one game is gone. Let's go ahead and give out another game. Awesome, Denlar. That sounds fun. That's always good. Is the raffle app written in .NET? No, it's written in Node, Node.js. It's written in Node.js, Googles. All right, guys, here we go. Good luck. One more raffle. Let's give out one more game and back to work. So good luck, everyone. Here we go. The next winner up is gonna be King Recycle. Hey, King Recycle, are you still out there, man? Are you still out there, King? Please say something in chat. Next 90 seconds so we can give you a game. Come on, man. Don't leave me hanging. A whopping 512. That's actually quite a bit, isn't it? That's actually quite a bit of memory. Oh, Darkfall. Man, look how instant that was. This guy knew exactly. He's like, I want some Darkfall. Darkfall, which one do you want, by the way? Do you want Darkfall 1 or Darkfall 2? Darkfall the Journal or Darkfall 2 Lights Out? Hey, Spyro. Darkfall 1. Okie smokies. This is... You just heard me repeat this, and that's okay. King, I'm going to send you a message here on Twitch. Please go check your Twitch message, respond with your email address, and we'll get this moving. Darkfall 3, The Darkening. Is that coming out next? Darkfall 3, The Darkening. Alright, we're going to get back to work here in a couple minutes, guys. Just let me get King's email. Let me get his game out to him. And we can do some cleanup and some fixes. And then now we'll be able to get our... Because we have a fixed 30-second frame send on the network. I want to extract that and improve that. Because I actually want to get to sending 60 snapshots a second. Okay, email sent. Because with 60 snapshots, we'll be able to get our playback buffer down from 300 milliseconds to 100 milliseconds. All right. Darkfall 1, The Journal, is going out. Congratulations. Check your email. Steam will be sending you a message right now. All right, guys, I'm stopping and resetting the raffle. We'll get back. Maybe we'll do another one at the end of the stream. But I want to get back to work now. I want to get back to work, right? Okay. What do we need to clean up? Let's go back from a consumer aspect and look at what the heck we're doing on the server. In our move server and see what might need to be fixed. Might need to be fixed. Right, so this is setting up a player, which is fine. I think I want to come up with an easy way to create a physics body, because right now it's a little messy. You got to create your own entity, and then you got to create your own physics component, and then bind them all together, and boom, Bob's your uncle. And that's okay. I guess everything is looking pretty fine right now, to tell you the truth. If we win raffle, set mood happy, else system out, print line. Good goals. Good work. This is actually fine. I'm actually okay with how that's looking. Let's go back through our component here. This is okay as well. What about our physics system? Oh, this is what I wanted to... Oh, thank you so much for the follow. Farseer, let's take a look. Let's go to World. And let's go to Step. I don't want solve. I want, okay, let's find step prop. Thank you, Merlin, for the follow. Okay, so take a time step. This performs, of course. If enable diagnostics, we're not doing that. It's going to process changes. Add and remove time. Okay, fine. Only moved position of velocity directions into settings. So this is going to do a step interval, it looks like. So it's creating a step, which is step interval dt. If it's greater than 0, then we use 1, otherwise it's just 0. Step, and there's our ratio. What's invert d? What is this set to? We're going to go find out. And we're going to update. I wonder if we pass this time step anywhere. So we solve for a time step. And solve TOI, auto clear forces. Oh, that's our last DT, is it? Let's see, hold on. What's our invert DT? Is our last inverted time step. And then we multiply that times new to get the new ratio. Interesting. All right, so let's go to solve. Oops, no. There we go. So that's at a step. Okay. 1 second here, guys. Sorry, just got to respond to a message. All right. So we're going to solve. If continuous physics, that's fine. Solve it by the TOI of the step. Auto clear. So we get the step DT right. But that's only if enable. Where do we use breakable bodies? Only if we're doing continuous fixes do we solve TOI. Otherwise, what are we doing? We collide. I think I'm going to keep my step that I have in there. Hi, how can you keep track of user input in a while loop to make a poll? It's not that difficult. So if you're using something like .NET, I'm just going to give it to you in .NET, right? .NET from console.readline. That's a blocking method, and it's going to block until somebody types something on the console and hits the enter key, and then you'll get that data back in readline. It will return that data. And you just put that in a while loop, and you'll constantly be able to readline and get data. You need a way to exit that while loop. So if somebody just hits enter on their own with no data, you just want to check the return value from console.readline. If it's an empty string, they didn't enter anything, and maybe use that to break out of your while loop, things like that. All right, sorry. So I looked that up, but I don't care. Because we have our own physics step time. And I want to get rid of, there's a few things I do want to get rid of. And see if things still work. Remove collision group, remove restitution. I don't want to set that. We want to expose restitution out a different way. And okay, let's see if this is working. Let's see if we're still working. We have no restitution, by the way, which means we don't have, we didn't bounce, right? So we're not setting restitution, so we just went boop, and we're done. So, let's see, body okay, so body can have restitution, but I think fixture can also have restitution. I think for now, we're just going to expose restitution at the body level, and think about if we want to expose restitution at the fixture level, because to do that we will have to come up with a fixture proxy. It's a pain in the ass right now because of how we have our setup, and I'm still thinking through my head if I want to redo some of this, but we will put a restitution. So public floats starting restitution. Let's spell things correctly. Would help, right? Sorry. Get and set. Yeah, that looks correct now. So we can set that in the physics system when I create a body.restitution is equal to pcomp.startingRest. Okay, now from the move server, we can say phys data starting restitution 1.0, and that should fix it. Yeah, these read line, yes. Debug, start. Okay, so we're still not getting restitution. I guess I do need to expose it to the fixtures. So what I'm gonna use is don't hate me because you ate me. Fixture.restitution is equal to the body.restitution. We will forward it on, I guess. Let's see if that works. Otherwise, I'm doing something wrong. I am, all right, so I'm doing something wrong. I'm doing restitution on the ball. Hold on, let me just double check to see if this fixes it. I'm not putting any restitution on our edge shapes. And maybe that's part of our problem. I don't know why it would, but let's see. Okay, so that's our problem. That's fine. Now, actually, here's a good question. If I take, I'm going to take that back off. Go away. We're going to go back to our move server and starting restitution and put that here. Let's see if that works or if I still have to forward it on to the fixtures. Okay, so I still have to forward it on to the fixtures. And that's fine. And just to be safe, I'm gonna put a breakpoint there real quick. Just make sure it's getting set to the right number. Oh, okay, so we don't actually want to set body.restitution. Which is kind of weird. Why is there restitution on body if it does not flow through? Let me see. Or I'm doing something wrong. And nope, that's fine. All right, so this should be good now. There we go. Our crazy bounces. Bounce like a mad fiend. Okay. Okay. Tick rates. Oh, well, also in our move server, just because it will annoy me eventually. We don't want you anymore. We don't want you anymore. Otherwise, everything else here is good to go. Good to go, right, guys? Now it's time to fix up our tick rates. Let's go to our config.json, and we want to set up some ticky rates. So we have max connections. Let's see, tick rates at the network level. We want we'll keep it to 30 at the moment, but then we'll be able to start messing with it. But now we also want physics. A physics block that we're going to go define. And this actually should, like the type, right? Physics should be 2D or 3D or whatever you're looking for. And then more importantly, what's the tick rate on this? And we're also running this at, we're actually going to bump this up to 60, which should be, let's see, 60, right, 0.016 is a 16. Oops, sorry. What am I thinking of? We're gonna do 16 milliseconds. Right, that's what I was looking for. So we're gonna bump our tick rate up to 60 for physics, but we only want a send rate on the network of 30. But it has a few properties that you have to set for adding the body simulator. I think they propagate on Activate or whatever they're called. Yeah. Why did I make you sad, Demlar? I'm not, guys, why does everyone still think I'm using XNA? Guys, I'm not using XNA. Oh, I see. Everyone sees XNA right here. All right, I'm going to make this easy for you. There we go. No longer will you see something like XNA. We don't use XNA. We don't use XNA. The physics library uses the XNA namespace to get vectors so that it can be binary compatible, essentially, between XNA and its physics library. You can pass vectors around. We don't use XNA. It's just a vector class. We're not developing a rendering system or engine here, right? Which means we're not no XNA. There's no client-side game engines. Just get a math library. I get that, Demlar. That doesn't help me though. We are using a third party. Remember, we're using a third party physics library. I can't just replace their math library in a third party library. And we're not using XNA. We don't have any XNA libraries in here. There's not one XNA binary being used in our system. It's purely a namespace. It's just a namespace that defines a vector class, which is all defined within the physics library that we're using. Nothing about XNA. So your analogy, unfortunately, is wrong. Bowl? Okay, all right. There being an update for us here, moving over to using near instead of mono game vectors. Oh, that'd be cool. Yeah, Shadow Draken. So we're using XNA basically. Ragathan, if that's true, I haven't seen it. I don't know. That might be in a branch somewhere that I don't know about, but that'd be cool. You're using the library because you're using a name. God, oh my God, Demlar, we're not using the XNA library. We're not. Here, I'm actually going to show you. So here's the Farseer's source code, right? Here's Farseer's source code. We are going to see some fun stuff. See, here's a Vector2 class. It's their class, right, that they happen to copy from XNA, but it's their class in the Farseer library. It just happens to use this XNA framework namespace. That's it. They just happen to use this namespace so that it can be compatible if you wanted to in XNA. Not that it is XNA. Oh my lord. So much talk about XNA when we don't use it. That's right, Rick. Let's do it. Okay. Tick rates. In our server, we're going to store a couple things. Floats our net tick time. Actually, I'm going to get a copy of our config. Net config, that's what I want. Net config, net config. Go to definitions. Add a new class. And we're going to call this physics config. Whoa, amazing. And the only thing we're going to have right now is a float. Public float. I forgot what I called it already. Tick rate. Very simple. Tick rates. Get set. Let's go to our physics config, or network config. Yeah, the same thing. I can't make a new one. We're using a third-party library. I can't replace a third-party library's classes. Bye, everybody. All right, so tick rates. Done. Physics config. Enough data. Okay. Back to our server now. When load config, let's see. Okay, so net config now. And physics config, get physics config for physics. Okay, and then here is physics oops. That's fine. This is physics config dot tick rate. And tick rate is, I want tick rate to be like 30, but we have to convert that. So we need to do a 1F divided by the tick rate. We need to convert our tick rate up, right? Because tick rate's going to come in as 30, but I want this in seconds. Basically, how many seconds should each tick take? You're pretty sure there's a new special paste letting you copy JSON and paste it as a class. I'm gonna have to check that out, Ragathan. I'm gonna find that. Is that in Visual Studio? Wait, let's just try it. So I can do this. I can basically copy that and then go up to Edit, Paste Special. Oh my god. Oh my god. Just has to be a valid JSON instance. That's pretty badass, Ragathan. That's pretty neat. That's pretty neato. Okay, anyway. We have our physics system going here now. I need to store 2 different rates. So float, net, accumulator, float, physics, accumulator. Okay. Actually, I don't have to worry about the physics accumulator. We're doing that internally. The net accumulator right now we have to do. So this means I can finally get rid of this. That's going away. Thank you. And then we're gonna update. But down here is we want to fix. So our net accumulator is plus or equal to our delta. Accumulator is plus equal to delta. Var ticks is 0. If net accumulator is greater than or equal to net config dot not that net config. We have a tick rate, but this is 1 divided by tick rate. Move this in. For, let's see, while net accumulator greater than or equal to 0. Oh, wait, hold on. No, net is greater than or equal to. Let's actually move this out. Var invert rates. So while we're greater, net accumulator minus equal to the inversion rates, and ticks are increased. The tuber on Twitch. The tuber on Twitch. What's up, man? How you doing? Okay, so we have our accumulator. We're gonna tick it down, right? We want to move this in. This means we definitely have at least 1 tick, and then say for int I 0 I less than ticks plus. Actually, Sorry, I'm gonna be lazy here. While ticks minus minus greater than 0. Let's give me the right ticks. We're gonna start with say 3 ticks, and then we'll have ticks will then boom will be 2, and then ticks will be 1. Yeah, that'll be good. Sorry, sometimes I gotta think about it in my head because math is hard. All right, so now we will send out our snapshots at our network tick rate, and only at our network tick rate. And questions, of course, is this still gonna work? So everything should still be the same if I just run this, unless I did something really bad. But now we can start playing with different rates. All right, so that's good, right? Everything looks as it has been. But now we can just go into config here and say our network, let's go ahead and send 60 ticks a second here. Let's see if that, I don't know if that's really gonna change anything. We're gonna go back and forth. We're gonna play with some data here right now. Because we're already pretty smooth, by the way. So we're just sending more data, which means this, the blue will not be as jittery because we're sending more data, but it's still gonna be a little jittery, where red looks super smooth still, right? But what we can do with sending more ticks is on the client, on our test client here, we don't need as big of a replay buffer. Right now we have a 300 millisecond replay buffer. And let's see, we have a tick rate, so we have tick rate of 60 now, right? And a replay buffer of 100 milliseconds. Let's see if this keeps us smooth still, or if it's too jittery in interpolation. Or it will be broken completely, because somehow I'm breaking it. What did I break? So, sorry, I'm just looking real quick. Why? Oh, we're doing, I wonder if it's because we might have to do a little bit of debugging here. We might not be sending 60 hold on. I have a bug in the server. When I send a snapshot, we get our, see right here, that's bad. We're hard coding 30 ticks there. That's not good. From the Asgard server, we need to just expose config data. And then on the move server, we should be using netconfig dot our tick rate, or just our tick rate directly. So that will synchronize that. And then of course on the client side, now we can switch this over to synchronize it. Otherwise, we won't be able to synchronize up interpolate packet IDs, basically. Okay, so we're doing a 100 millisecond lag buffer now, which means if you watch how close we are to the left-hand side, this is the server, this is the right-hand side. We're actually a lot closer than what we were before, right? Because I'm going to switch this to 10 in a moment. You can see just how far off this can get. And on top of that, since we're only 100 milliseconds, actually, we can see how close we are to blue, right? Blue is real-time network data. Red is we're interpolating to there. You see how close red is to blue? In a lot of instances, red is actually able to catch up to blue before it pops back. So we're very, very close in time. We're just 100 milliseconds behind the simulation. That's not bad at all. That's pretty damn good. I have not played Undertale. That's pretty darn awesome, right? And of course, if we switch back to a 300 millisecond buffer, you will see how bad this is. See how far away red is from blue? Because we're now 300 milliseconds back in time. And that's why we want to send, that's our trade-off, by the way. In a snapshot interpolated network simulation, our trade-off is bandwidth to lag. If we want to reduce our playback time or how far in the past we can render, if we want to squeeze that down, we have to send out more data to every client. It's just, that's just the game, right? You have to send out more snapshots per second so that there's more potential data in the buffer for dropped packets to interpolate between to have that work. And that's why we went from 30 to 60 frames a second on snapshots a second to the client, which means we're able to drop this down to just 100 milliseconds instead of 30, or instead of 300. But guys, that is it for the day. We're about 6 hours into the stream, so I'm going to be calling it an afternoon. I hope you guys had fun. I'll be back early tomorrow morning, so come on back, come hang out with me. We're going to get some more stuff going. We're probably going to start working on player network interpolation, which is a player-controlled character, which is a lot different than just our lag simulation that we're doing right now. But come on back tomorrow, guys. Hope you guys had fun. Hope you had fun. Stay safe today. Until next time.